P3, M1, and S2. So now this is kind of like a new kind of a session for me in which the camera is pointing towards me. Not only I have to look at the camera and teach you people. So now the thing is all about that getting stuff done. P3, M1, S2 is just right around the corner. And the whole objective is to make you understand the last minute necessary details that will ensure that you will get amazing results in your upcoming exams. So now let's get to the thing. Uh, let's start with P3. So we are starting with P3. And the paper that I've selected is this particular paper. So now let me start underlining it. So this is a P3 paper. And this is of May, June 2024. And this variant is 32. So the second variant. Now, the first thing is when we start with a paper, so what exactly do we have in mind? Of course, the anxiety is there. But the main thing is that in the best possible time, you have to complete the paper. One of the things that the examiner asks is that something very obvious, something very trivial, that is that make sure that you read the question. So, I mean, some things, there are some things that we take for granted, but the question reading is a must. The second thing is answer all questions. These are the basic stuff that you need. And this one, that is the one that is most needed, which is you should use a calculator where appropriate. That means it's not necessary that every time you have to use a calculator. Where appropriate, that's when you have to use it. And the most important of everything is that the most important stuff. That is, you must show all necessary working clearly. Do not assume anything. Believe me that. Write down every single detail, every single step in the manner that you have seen on the alt lectures, the recorded lectures, as well as what you're going to see right now. No marks will be given for unsupported answer from a calculator. Why should you be given the marks when the calculator is doing all the stuff? So that means you should show all the working, you should work out everything, and then you have to reach a conclusion. The next thing that is important is that give non-exact numerical answers. That means if the answer is exact, what's the point of rounding off? If it's 0.58 and it's exact, 58 over 100, 0.58. So leave it as it is. No need to round off. If it's inexact, we have to round correct to 3SF or 1 dp for angle in degrees. That means, let me write it down. That means work in 4SF for all the calculation, including angle in radians, and work in 2 decimal places for angle in degrees. Unless what happens? Unless a different level of accuracy is specified in the question. So if they say that give the answer correct to the nearest integer, we should give the answer correct to the nearest integer. The total mark is 75. The number of marks for each question is given. So now, what are the main topics that we focus on? First of all, we can have a question on algebra. And let me put all the dots over here. And we can have a question on logs and exponential. Indices can also be used as the terminology, or we can write exponential. There is trigonometry, then there is differentiation, there is integration, the word problems of integration, that is known as differential equations. And then we have this thing, which is vectors. We have complex numbers. And then, of course, there is a ninth one. One more dot is needed. That is numerical solution of equations. So now out of these 9 topics, let's see what are the topics that appear on the exam. Of course, almost every time they do ask a topic. Exceptions could be there. But over here, these 9 topics may be in algebra. They might be asking about partial fractions. They might be asking about modulus inequality. The question could be about binomial. The question could be about polynomial. In logs and indices, definitely the concept of logs is there, the concept of indices is there. There are equations which require substitution. Then there is something called linear law. So these are the basic stuff that we need. So now let me just click this thing. Okay. So now when we talk about all these things, the main idea is whenever you have a question, so make sure that particular tab gets opened up in your head. Make sure that if we talk about linear law, it's about coordinate geometry, it's about gradient, y-intercept, it's about logs naturally. When we talk about partial fractions, all the cases of partial fractions should be in your head. And then you will proceed with that. So now in trigonometry, let me just go to this one, the main thing. So now in trigonometry, we should know that it could be about degrees, it could be about radians, it could be about addition formula, it could be about double angle, compound angle formula. So everything should be there. Differentiation, the basic differentiation, that is the basics of P1. Then there is product and quotient rule. And then there is exponential, then there is ln, then there is sine and cos and tangent, sometimes using the chain rule, sometimes using the basic integration, the product and quotient, and 1 over sine, 1 over cos, 1 over tan, everything could be asked for. Naturally, there is also differentiation using implicit differentiation. There is parametric. So this is the variety of differentiation. Integration, much more variety. You know exactly what are the different things that come in integration. Again, it could be about basics. It could be about substitution. It could be about integration by parts. A whole big chapter of trigonometry is there. And what else is there? Trigonometric identity, trigonometric substitution, and many more things. The concept of area, the concept of volume, partial fractions is involved over here. Integration, that gives you ln 1 over ax plus b dx, that gives you 1 over a ln ax plus b plus c. So things like that. Differential equations, we'll look at the problem and then we'll decide. Vectors, basically after O levels, it's directly to A2. So we connect the idea from O level maths all the way to A2. There used to be vectors in AS level, but after the 2020 syllabus, it's gone. Complex numbers, it's not that complex. It's very, very conceptual, as you will see right now. Numerical solution of equations, it's also popularly known by the name iteration. So now just a brief overview of what we are expecting to see it. And one of the things that I want to focus on is the idea of looking at the examiner report. Now, one of the ways is that I can look at the examiner report after I'm done with the paper. Let's go ahead and let's look at the examiner report first. And what I'll do is that we will discuss a particular variant. We will discuss some things related to what you call maybe brushing up on a particular technique or something. And what else is there? Then we will look at the other examiner reports also. So now this is over here. What you see is that 9709 Mathematics, June 2024, Principal Examiner Report for Teachers. So, of course, the students can also benefit from it. What are the key messages? This is for the variant 32. Read the question very carefully and make sure that your response matches the demand. I think the examiner, of course, cannot be sarcastic, but there is a hint of sarcasm over here. That is why don't the people have this much of logic that they should read the question thoroughly. They should understand what is being asked. If it's asked in the exact form, if it's asked in the decimal form, what is the level of accuracy? What are the steps that's needed? For example, if they ask for the stationary point, that means calculate, evaluate, find an expression for dy by dx and then make it equal to 0. That is what is expected. If they ask for the nature of the stationary point, then second derivative test is there. So now these are the different things that is needed. So the first thing first is read the question very carefully. So it's read, it's very carefully. Make sure your response matches the demand. For example, finding the point of intersection of two lines is not the same as showing that the two lines intersect. A very good point. This is with respect to vectors that they are talking about. The first thing is they're asking, show that the lines intersect. So now you must have done a question like that in which whatever the parameter that you use, maybe that parameter is lambda and mu. And if it satisfies all three equations, lines intersect. If it does not satisfy, therefore the lines do not intersect. And the next phase, the next step is that you find the point of intersection, place lambda where it belongs or place mu where it belongs. The next thing that they are focusing on is this thing, that is use mathematical notation correctly. What does it mean? It means that the omission of brackets in algebraic argument can turn a response with potential into not being worthy. Now, this kind of wording is the first time that I'm seeing. That is, this examiner is really ticked off and he's not so happy with the way that people have given the responses. So, what the examiner is trying to say is that at least have this much of common sense to use a bracket. Uh, why brackets are for free? Use as much as possible. So, use the bracket, keep things intact so that you don't make a mistake. So, it says that over here, the omission of brackets in algebraic argument can turn a response with potential into not being worthy. That means, for example, 2y minus 1 ln A is equals to x minus y ln B, and this thing are not identical. So this looks like this is 1 into ln A. This looks like y into ln B. I think it's a very, very good example. And this is the first time that I'm seeing that they are giving example in the key messages. People, what I ask from you is that at least go over the key messages so that you have a complete idea exactly what the examiner is concerned about, what the examiner is expecting of you. The next one, that is this thing. If a question asks you to prove a particular result, then the response needs to be very clear about what each fact demonstrates. Let's read further. For example, if a question asks you to demonstrate that the triangle is isosceles, it is not sufficient to find the length of the sides. You need to say that because two of the sides are have equal length, then the triangle is isosceles. I think that's very common sense, and I don't know why people just assume that the examiner will do all the working for them. So now the thing is, you find the length of all the three sides, and then you say that these two sides are equal. Therefore, it is isosceles. As simple as this. You must make deductions. You must make deductions. Do not leave that to the examiner. Believe me, I did not read this. Um, it says exactly what I just implied. And then it says candidates who give a first draft of a response in pencil and then write over it in ink should be aware that the responses does not scan well. That means that some people are not so confident. Well, if you're not so confident, just do that little bit of working somewhere on the site and then do it once in your main script of the answer. Do not be writing in pencil, then overwriting with pen. It looks dirty. And then using an eraser with all that eraser marks spread out over here. So when the examiner will open the paper, the first thing that will fall off is that the eraser, all those leftovers. And the examiner is asking you people to be very, very careful with that so that your grades doesn't fall. So now the next one, it says when a question asks for an exact answer, I mean, this I have emphasized over and over again. Do not work in decimals and then say, okay, this is the same thing as the exact answer. The examiner does not like that. This is not the same as stating all the decimal places that your calculator will give you. That is an end to the window. That is inexact. Exact answer means what? Exact answer means fraction. It means third form. It means in terms of pi. It means in terms of ln. It means in terms of e. This is all exact. So now what does it say? It says over here that is the answer might be a value involving thirds or multiples of a constant such as pi or e. Pi or e, ln is also there, and fractions is also exact. And let's now start with the paper. So now the paper gives us the first question. By the way, this paper is already solved for you. I'll go over all the necessary details. It's a walkthrough solution. It says sketch the graph of y is equals to x minus 2a, the whole thing modulus, where a is a positive constant. Now, first of all, x minus 2a, make y equals to 0, x minus 2a equals to 0, x is equals to 2a. So it's a positive constant. That means 2a is also positive. So this is the first thing that I've drawn. That I've drawn a line like this and nothing else. And I have reflected this portion of the graph. So now it's time to cut it off. This portion of the graph is slashed. And this is reflected in this x-axis. So make sure that this angle and this angle is approximately the same because it has the same inclination, except this has a positive slope, this has a negative slope. And this V-shaped graph is the graph of this modulus. That's all what is required. Now the second part, it says solve the inequality 2x minus 3a is less than modulus of x minus 2a. Now, the first thing that I want to emphasize is that the examiner will never force a way that you have to follow. It will simply ask that you have drawn the first part as graph. That was the requirement. No one is saying that you should solve the second part with the graph also. So now with unknown values like this, I mean, it is kind of tricky to draw this. What I'll do is that I'll just apply the basic algebra way. So let me do it algebraically. And there are the cases that I've defined. If you have watched the video in a very calm manner, you would remember that what are the different cases that I have decided on. So let me write it out. Case number one, that is x modulus is less than a. That is the same thing as x lies between negative a and positive a. That's the first one. Let me just change the color. Case number two, that is modulus of x is greater than a. That's the same thing as x is lesser than negative a, comma, x is greater than positive a. And similarly, we have case number three, that is modulus on both sides. So the rule is square both sides. You would either get a linear inequality or you would get a quadratic inequality. So one of these two choices are there. So let me write inequality. Let me write inequality. Now, first of all, uh, the working for this that was shown, and this is the result that we have to apply. So there is modulus on left hand side, and then there is a lesser sign. There is modulus on left hand side, then there is a greater sign. There is modulus on both sides. Inequality doesn't make a difference, by the way. So now modulus is on right hand side. So the very first thing that I'll do is that I'll write the modulus on the left. That is the first thing and foremost thing that I'll do. Okay. And then what is the next step? The next step is, since it involves a greater sign, so therefore x minus 2a, that is this case, case number 2. x is lesser than negative a. This whole thing is like x and this is like a. So x minus 2a is lesser than negative of this thing. X minus 2a is greater than positive of this thing. You simplify, you get x is lesser than 5/3 a. X is lesser than a. Now, when this is the scenario, there are four different scenarios. Just have a look. Look at my hands. The two inequalities are pointing towards each other. Overlapping region is the answer. Two inequalities are divergent from each other. Both the answers are there. But either two inequalities are moving in one direction or in the other direction, then we apply something known as the true false test, such as this. What we do is that we draw these two inequalities on the number line. X is lesser than 5/3 a, that is the blue line. X is lesser than a, that is the red line. And the number line is over here. This is a, 5/3 a definitely is greater than a. Choose a number within this range that is lesser than a. I could have chosen 0. I chose half a. I could have chosen negative half a, and so on. Between a and 5/3 a. 5/3 is basically 1 whole 2/3. So a little lesser is 1.5a, 3 over 2a. Let me choose this, plug in the original inequality. Let me choose this number, plug in the original inequality. When we simplify, 3 over 2a is greater than negative 2a. Is this true? Yes. That means this whole inequality is true. Doesn't make a difference what value you put in from this range. That is always true. And then this number represents this part of the inequality from here to here. And this is also true. That means this portion is true. This portion is true. That means the whole blue line is true. Therefore, the final answer is x is lesser than 5 over 3a. Now, some people, they ask this question, what if this one was true? For example, this is true and this is false. Then only this will be the answer. What if this one is false, this one is true, this number represents this thing, then this a, this x lies between 5 over 3a, and a will have been the answer. So that is a question related to modulus inequality. Now let me go to the examiner report and let's look at the first question. So let me just highlight this. I think this is too dark. So this is question number 1. This is modulus, graph, and inequality. Now the question says, many candidates identified that the sketch should be a symmetrical V shape. For a sketch of this nature, the points of intersection with the axes must be shown. In this example, the points of intersection should be at 2a on both axes. Okay, I forgot the y-axis thing. I'll just go ahead and correct it. The most common error were a sketch of the wrong shape, a sketch of the correct shape but in the wrong place, or missing slash incorrect markings on the axes. Several candidates attributed a value to a. You don't have to. You have to write it in terms of a. Achha, someone asked this question, how is x is less than a? How is x less than a? When you solve this thing, x minus 2a is greater than 2x minus 3a. You take this on the other side, minus x is greater than minus a. Get rid of the negative sign. I mean, that is one confusion that people do have, is that since there is a negative sign on both sides, the minus cancels out. Yes, the minus does cancel out, but the inequality flips. Think of it this way. Let me take this over here. Let me take this over here. So this is a is greater than x. Read it like this. From the perspective of x, from the vantage point of x, x is lesser than a. That's how you get it. So whoever asked this question, Legend 47, I think you got this clear. The second part. Now the question says, some candidates worked from a correct sketch and added this line. These candidates usually deduce that there was only one critical value. They often obtained the correct answer. Many candidates chose to square the inequality to remove the modulus sign. Squaring is only applicable when there is modulus on both sides. If you square both sides in case 1 or case 2, sometimes you give an extra solution which you do not know whether it exists in reality or not. There were many slips in algebra, particularly because the involvement of A in the working, the critical values are such and such. It was unusual for x is equals to A to be rejected. So the examiner kind of missed out over here that maybe they are not used to identifying or classifying things as cases. So basically, what they have done is that they should have written that x modulus is less than a. So actually, it's greater than a. X modulus greater than a. That is the breakup. S x is lesser than negative a. X is greater than a. Now, for some people out there, let me just explain this thing how this is obtained. X with a plus sign is greater than a. X with a negative sign is greater than a. This remains as it is, therefore x is lesser than minus a. And when we draw these two on the number line, this is negative a, it's going in this direction, positive a, it's going in this direction. That is how we obtain this. So just go through the regular class lectures, the alt lectures in which everything is broken down into small bits and pieces. And over there, everything is explained over there. Question number 2. Now this is partial fraction. So let me just highlight this over here. So this is partial fractions. And over here, this one is modulus. And this is sketch. And this is what you call inequality. So now over here, what is the first thing? My question to you people who are watching this live, what is the first thing that you should observe when you come across a question of modulus inequality? So now the very first thing that you observe is that what is the highest power over here? So let me just focus on this. What is the highest power in the numerator? What is the highest power in the denominator? The two powers are equal. Therefore, this is an improper algebraic fraction. That is the first thing. So that brings us to the first thing, that is, if it's an improper algebraic fraction, we divide, we get a quotient and a remainder and a divisor. And then for this remainder and divisor, we will break it up into partial fractions. And at the end, we should not forget the cube. So now this is what I've outlined over here, that this is what you are supposed to do. So now the very first thing, the step number 1, let me write over here. So step number 1 is long division. Some people, they prefer to do it using an identity. I prefer long division because long division will make sure that your polynomial division, the long division, the algebraic division gets enhanced every time, because polynomials again is a separate part of it. And you should get this thing over here. So now check the powers in the denominator and this thing. Perfect. So now over here, what we do is that 6x squared over 2x squared, that is 3. Multiply 3 with each one of them. And what you get is that 6x squared minus 15x minus 36. Change the sign and add. So this gives you 6x plus 20. That is all good, all clear. So now over here, what we can do is that, let me just correct it. Okay. So now the next thing that we need to do is that we get a quotient, remainder, divisor. So this is quotient, this is remainder, this is divisor, and we write this thing as quotient plus remainder over divisor. So now let me write this thing over here. One thing over here, that is quotient plus remainder 6x plus 20 over divisor, that is 2x squared minus 5x minus 12. And now we will start with this thing, and then we will break it up into partial fractions. That is the thing that we need to do. So basically, step 2 is partial fraction. But over here, that's an intermediate step, that is factorize the denominator. Now, when we factorize the denominator, that is just middle term factorization. And over here, This is 2x squared minus 5x minus 12. You get x minus 4, 2x plus 3. So now which case is this? This is a case of denominator with linear factors. So let me write it over here. Denominator with linear factors. So the rule is you break it up, a constant over the first linear factor, another constant over the second linear factor. You take LCM. So the LCM is x minus 4, 2x plus 3. I skipped a step. This A gets multiplied with this B gets multiplied with this. Both the sides are identical. And then you would say that this thing over here, 6x plus 2 is A times 2x plus 3, B times x minus 4. And then we use the concept of substituting different values. So substitution to find unknown constants A and B. Now you have to make a wise substitution. That is, if I choose x is equals to 4, so this constant will disappear. I'll find the value of A. So let me write down the value of A. A comes out to be 4. Now, one other way is that I can make 2x plus 3 equals to 0. Therefore, x is minus 3 over 2, and I can find the value of B. But this time I chose a different approach. What I did is that I plugged in this value, and then I chose a simple value, x is equals to 0, which I have not used before, and I find the value of B, that is negative 2. So we have found A, we have found B. The final answer, don't forget the quotient. So this is the quotient, and this is the quotient right over here. That is A, that is B. The minus sign is right over here. So that was a basic question of this thing, that is partial fraction. So I think it's all good, all clear. Let's move on. Question number 3. Now, question number 3, this is about logs and exponential. So logs and exponential, and in particular, this is about something known as linear law. It's kind of like that. So now it's a different kind of a question. I like this question. It says the variables x and y satisfying the equation. You need to keep drinking because you have a long way to go. And it's a marathon. Let me just increase the power. Okay, now all good, all clear. So now it says the variables x and y satisfy the equation such and such, where a and b are constants. Show that the graph of y against x is a straight line. So now over here, I can either take ln or lg of both sides. It doesn't make a difference. I have taken natural log of both sides, ln of this side, ln of this side. Now this power comes down and multiplies, this power comes down and multiplies, and maybe that is one of the reasons where the examiner was finding the thing that people have not used the brackets. So of course the brackets were not there originally, but as soon as I take it down, I put a bracket. As soon as I take it down, I put a bracket. So the bracket is there, the bracket is there. And then we have this ln A, this is ln B. And then what's the next logical step? Open this up, open this up, open this up, open this up. And then gather all the y terms on one side. So now if I'm looking for the y terms, that's the y1, that's the y1, and everything else on the right hand side. That is over here. So now you make y the subject, and then we are getting this thing in the form that is y is equals to mx plus c. You have to get this in this form. So over here, this is y all alone. The coefficient of x is ln b over 2 ln a plus ln b, which can be written as ln of a square plus ln b, which is ln a square b. The working is done right over here at this corner. So that is the working. That is for 2 ln a plus ln b. That thing is done. And that's again written over here, and this is your y-intercept, which is c. What are they asking? Sketch, show that the graph is a straight line. Why is it a straight line? It is a straight line because it follows the format y is equals to mx plus c. That is what you should write. And one more thing which I missed out, let me correct myself. That is over here, when x is 0, y is equals to 2a. So when x is 0, uh, y is equals to negative 2a. So that's negative 2a was over here. And there is a 2a over here. And this is what was needed to be labeled. So that is something that I missed. And I don't want you to miss it. So we have done it all correctly. Uh, Hi, sir. What paper is this? May, June 2024. Thank you. Okay, now let's get started. Given that A is equals to B cube, state the equation of the straight line in this form where P and Q are rational numbers in their simplest form. Now, first of all, this is ln B, this is ln A square B, this is ln A, this is ln A square B. So if A is equals to B cube, I'm replacing A with B cube. There is a square on the outside. This is 3 into 2. This is not 3 plus 2. This is 3 into 2. A power m raised to power of n, that is a m n. So 3 into 2 is 6. 6 plus 1 is 7. ln b raised to power of 7. 7 comes down. 7 ln b. So now this is the denominator. This is ln b at the top. ln b over 7 ln b. ln b cancels out. This is 1 over 7. This is your gradient. And this is ln A over this thing. ln A is replaced with B cube, that is 3 ln B. 3 ln B over 7 ln B, that is 3 over 7. And that is how you get this equation. Just have a good look at it. Okay. I hope it's all good, all clear. Some people who have just joined in, they can have a good look at it. I'll then proceed. Okay. Let's move on. So now question 2 was about partial fraction. Question number 3 was about log and exponential. Let me go to this thing. So question 2 was about PF, and question 3 is about logs and exponential. In particular, this is linear log. Now let's have a look. What are the things? What are the issues that are being raised over here? Okay, now over here, there were two aspects of this question that caused difficulties. The numerator of the fraction is the same degree as the denominator, and the denominator is not given in factorized form. So let me highlight this. There were two aspects that caused difficulties. Numerator is same degree as denominator, and the denominator is not given a factorized form. Neither of these points delayed the candidates, but they did result in many errors. A large minority of candidates did what they were expected to do. A large minority, that's a good one. Obtain three constants with no difficulty. Some started by dividing the numerator and denominator. I'm one of those who start dividing the numerator and denominator. Or some worked from the form y is equals to a, that is in place of the quotient, b over 2x plus 3, c over x minus 4. Many errors stem to use this thing. What is the error? The error is cannot proceed unless we have a proper fraction. So we cannot proceed to partial fractions unless we have a proper fraction. So partial fraction is different, proper fraction is different. Okay, now someone is asking when is the M1 paper? M1 paper will start, I think it's at 8:30, approximately like that. I mean, just check the thing. So it's a 2-hour session for this and a 1-hour session for this one and the 1-hour session for this one. I think this is like 75 minutes or something. Some even did factorization like this. I mean, that is very strange. That is very strange why some people would do a factorization like this. So this is not good. And I think I should just give a comment. So that is this thing. I mean, I'm not sure how many of you are familiar with Uncle Roger, but that is what he will write. That this is not good, not clear. So now let's talk about this thing. The other question, let me just put it over here. The majority of the candidates made a correct start. This is for linear law, usually by taking logarithm of both sides of the equation to obtain this thing or equivalent. It was common for the brackets to be omitted. I mean, that is again not a good thing. It was common. They're talking about a mistake for the brackets to be omitted. Another common feature of the work this year was incorrect cancelling to obtain this thing. I mean, some people just cancelled off the ln. I mean, that is very strange. That is just like saying, let me give you on a lighter mode, 64 over 16. We know the answer is what? 4. Now, if someone says, I like 6 very much, I like 6 very much, let me cancel these two. And then 4 over 1 is the answer. That is a wrong way, but it's giving us a correct answer. So the method has to be correct. Over here, you just cannot cancel ln. Many candidates who obtained a correct form of the equation did not go on to compare it with the standard form for the equation of a line in order to reach the required conclusion. That means they got the format, but they did not what you call correlate with the equation of a line. Okay. The second part, that is, this part of the question was comparatively well done. I'm again amazed. Some candidates worked from the equation in part A, some reverted to original index form. There were several fully correct solutions. A common error was not to simplify further. You have to simplify further. Okay, now this thing is all good, all clear, and we will come back to the examiner report shortly. So now sometimes when we go to the examiner report at the very end, things are already too saturated. So one or two questions, look at the examiner report, get the message, let's proceed. Now question number 4, what is this question all about? Question number 4 is all about the concept of implicit differentiation or differentiation of implicit functions. Uh, Will you also be going over paper 2? No, I'll just be going over paper 3, this one over here. Okay, so now the question says, the equation of a curve is y e raised to power of 2x, y square ex is equals to 6. What is the concept? Differentiate both sides with respect to x. Two things are multiplying over here, two things are multiplying over here. Now, things is a layman's term for two functions of x or y. They are multiplying with each other. And then it says find the gradient at the point where y is equals to 1. So we are interested in evaluation rather than an expression. Keep that in mind. So interested in evaluation rather than expression. So now when two things are multiplying over here, product rule applies. This is u, this is v prime, this is v, this is u prime, this is u, this is v prime, this is v, this is u prime. Now, the rule of implicit differentiation is whenever you differentiate x with respect to x, everything is normal. But whenever you differentiate y with respect to x, you get 1, which is the rule. But you also get a y prime. You differentiate x, you get 1. You differentiate y, you get 1 into y prime. Similarly, over here, y square into ex, ex into y square, derivative of y square is 2y, y prime. Now this has a y prime in it, this has a y prime in it. Now there are two options. Either I find the expression and then plug in the value, or I plug in the value and then evaluate the expression. I opted for the second choice. So what I've done is that when y is equals to 1, where is the working that I've done? So over here, when y is equals to 1, what we do is that we find the corresponding value of x. So I think I just got it erased somewhere. Okay. So now over here, let me just do the working. I think it got erased. When y is equals to 1, okay, there it is over here. So this thing is there. Let me put a box. When y is equals to 1, find x value. So let me just put it inside a blue box. Okay. Now this is basically step number 1. It's written on the sidelines. This is step 1. Now it says when y is 1, find x. So when y is 1, this is 1, this is 1, e power 2x, e power x is equals to 6. E power 2x plus e power x is equals to 6. And then take the 6 on the other side, make a substitution. This is about logarithm and indices. So now over here, when we talk about logarithm and indices, the thing is that this chapter of logs has application in every other chapter, almost. Uh, Something like differentiation, integration, differential equations, maybe numerical solution, and of course, logs itself. So now over here, we do the substitution, we get this thing. We do the middle term factorization, we get two values of m. But what is m? M is e raised to power of x. E raised to power of x is 2, therefore x is ln 2 by taking ln of both sides. E raised to power of x is negative 3, no solution because ln of negative number, ln of 0 does not exist. All good? All clear? Some people, they are asking this question, this is not mechanics, not yet. This is P3. I think at this point, yes, there will be a mechanics stream. It will be one single stream. The first part is P3, the second part is M1, the third part is S2. So that is the way in which we'll be going. So sit back and relax. So now over here, what I do is that I have written y as 1 and I have written the value of x as ln 2. So this is 2e 2e 2x. Instead of x, I have written ln 2. Instead of x, I have written ln 2. Instead of x, again ln 2. Instead of x, that is ln 2. Now, there is another thing that's very important. That is e raised to power of ln x is x. Now, some people, they ask this question who have not studied thoroughly. That is, how do we get this rule? So the rule is derived from this idea, f of f inverse x is equals to x. F inverse of fx also equals to x. If I say fx is ex, and if I say f inverse x is ln x, try it out. Plug this thing over here, f inverse inside fx. F of f inverse x, that is e raised to power of ln x, and the answer is x, provided x should be positive, because ln does not exist for negative number. Similarly, f inverse of fx, that means fx over here, that is ln of ex, which of course we know the rule, x ln e, which comes out to be x. So this rule is derived from here. So now what I've done is that I have made 2 the power of ln 2, that is 2 square, which is 4, 2 the power of ln 2. This remains as it is, this remains as it is. So e raised to power of ln 4 is 4, e raised to power of ln 4 is 4, e raised to power of ln 2 is 2, e raised to power of ln 2 is 2. And the rest is just simplification. We find the value of y prime, which is minus 5 over 4. They are simply asking for the gradient. Okay, all good, all clear. So question number 4. Let me do one other question and then I'll go to the examiner report. So now it says it is given that the equation has only one root. Now, what is this? What is the name of this particular chapter? The name of this particular chapter is what? This is numerical solution of equation. Now, let me just check one thing. That is over here. Let me just check. Okay, so some people, they ask this question. Let me write it over here so that they are well aware. There are 3 sessions over here. The first one, that is P3, 6:30 to 8:10. That is P3, it's 7:21 right now. The next session is M1, that is 8:15 to 9:25. And the third session is S2, so that is 9:30 to 10:30. So these are the 3 sessions. Okay, let's proceed. So now over here, it says it is given that the equation is this, has only one root. Show by calculation this root lies in the interval 0.7 to 0.8. Now, the very first thing is that take everything to one side of the equation, preferably the left hand side. So therefore, this is e raised to power of 2x minus 5 minus cos 3x is equals to 0. Fx is equals to e raised to power of 2x minus 5 minus cos 3x minus cosine of 3x. Make sure your calculator is in the radian mode. So that is a must. The calculator is in the radian mode because the angles are in radians. And we plug in zero point 0.7 over here. So we plug in zero point 0.7 and let me just grab this. So we plug in 0.7 and then we plug in 0.8 and one of the values is coming out to be negative. One of the value is coming out to be positive. And since there is a change of sign, since there is a change of sign, this is called change of sign test. Therefore, root lies between zero point 0.7 and zero point 0.8. Again, stick to the idea of concluding everything, making a logical deduction. The second part, show that if a sequence of values in the interval given by the iterative formula, this is the iterative formula. So let me just highlight this. So this is the iterative formula. If this iterative formula is given, sequence of values given by the iterative formula converges, then it converges to the root of the equation in part A. Now, what does that mean? That means that both these equations are exactly the same. It's just a different way of writing it out. This is known as an equation. Now look at this. This is equation. This is iterative formula. Basically, what we do is that we write it in this form. X in plus 1 is a function of x in. That means 1x on the left hand side, that is made the subject, everything else on the right hand side. So this is known as the iterative formula. You have studied it. So now there are two options. The first option is prove the equation equal to this or remove the subscript and then make it equal to the equation. Both are perfectly good. So now over here, what I have done is that I have started with the equation and I have gone to the iterative formula. That's the thing I've done. What exactly have I done? I have done take natural log of both sides. If I take natural log of both sides, again, a bracket is a must. Maybe not at this stage, but as soon as you take ln, it has to be of both sides. This 2x comes down, ln of e becomes 1, 2x is equals to ln of this thing. So let me write it over here, 5 plus cosine 3x. Therefore, ln e 1. Therefore, x is half, 5 plus cosine 3x. And then underneath, you write n plus 1 and then you write a n over here, just following this pattern. Now, let's say someone asks me to do it the other way. So let me go to the iterative formula and let me change it to the equation. So the iterative formula is xn plus 1 is half ln 5 plus cosine 3xn. Now let me remove this thing. Let me remove this thing. Why? Because after successful iteration, the input and the output becomes the same. Just cross multiply. So therefore 2x is equals to ln of 5 plus cosine 3x, 5 plus cosine 3x, and the base is e, therefore e raised to power of 2x is 5 plus cosine 3x. So this is also a good way. Both ways are perfectly fine. Again, which chapter are we using over here? ln. Which chapter have we used over here? Again, logs and indices. Again, logs and indices. Maybe if this was related to integration, logs and indices, but not now. And this is modulus. So now just understand the importance, the power of natural log. How important of a chapter is it? So now the third part, and before we go to that thing, the examiner report. Now it says use the iterative formula uh, to determine the roots correct to 3 decimal places. Give the result of each iteration to 5 decimal places. So it says the root lies between 0.7 and 0.8. So we start with the starting value. So we start with the starting value and this starting value is half, zero point 0.7 and zero point 0.8. That is the best value. Therefore, it comes out to be 0.75. So that is the starting value, the input value. We plug in 0.75. In this iterative formula, half 5 plus cosine 3x, the value of x is 0.75. And we get this thing 1, 2, 3, 4, 5. This is 5 dp. Now, x1 is 0.73759, and we get this next value again 5 dp. Then the again input value is 0.74094, and the next value is 0.74003. Now wait a minute. Round it off to 3 dp. What do you get? This comes out to be 0.741. This comes out to be 0.740. Just do one more step, and which I have not done. I think I skipped it. So this is 0.74003, and we get x4. It will be stuck over here, and it will round off to 0.740. If you get two successful iteration which have the same thing, that is the answer. So that is the answer. That is the root of this equation. That is the solution of this equation. So now let's look over here. Many candidates coped well with implicit differentiation. So let me get this thing handy. This question number 4 was about implicit. The notation y prime was used by some candidates. This was often accurate, but in some candidates confuse the y prime with the y. So a few candidates retain 6 after differentiation. They are talking about a mistake. Finding the value of x when y is equals to 1 was much more problematic. Again, I'm emphasizing on this thing. That is that you have to do this thing over and over again. That is natural logs. Now, someone asked this thing, hello, everything for 9708 paper 42. I think it's 9709 paper 42. Yes, that will be starting at 8:15. That's right over here. So just have a look. I think I just wrote it somewhere over here. So this is P3. This is M1 and this is S2. So let me continue with my work because this is causing a little bit of distraction. So let's move ahead. Some candidates did not realize that this was necessary, and many candidates manipulated the exponential equation incorrectly. It was common for candidates to logarithm of the terms separately. That is a big sin in math. You take natural log of both sides. You cannot take logarithms or square root of each term separately. Those candidates who showed clear formation of the correct quadratic in EX often obtain EX is equals to 2. Some candidates did not reject. Now, this is one thing which people ask. That is, do we have to show the rejection? The answer is yes. People ask this question that if we are not taking an answer, should we show this? Yes, we should show this. We should show this. So a few candidates did not reject the negative root of the quadratic equation and continued with two solutions. How can you take ln of a negative number? A few candidates created difficulties for themselves by substituting the x for ex in that equation. I mean, the world is full of people who make all these permutation combinations of S1 in every other maths paper. Sign errors in rearranging and substituting to obtain the gradient were relatively frequent, and fully correct solutions were unusual. There was nothing wrong with this. No one was asking for an expression. All you have to do is to plug in the value. And of course, you can also use the calculator, the rule that I've explained over there, e power ln x. Very, very important rule. Remember this because it's going to come again also. Anytime, you never know. E raised to power of ln x is equals to x provided x is greater than 0. Very, very important rule in differential equations, in integration and substitution. Candidates who substitute their values prior to rearranging save themselves a lot of writing and were often more accurate. Yes, we are one of them because that's the correct way that I have taught you. There was no need of rearranging. Substitute in the value, make it the subject. Okay, thank you. Question number 5. It was pleasing to know many fully correct responses. Some candidates obtained correct relevant values but did not draw a clear conclusion. Most errors were due to working in degrees rather than in radians. Whenever you are dealing with differentiation, integration, numerical solution, and differential equations, radians is the standard, the gold standard. The majority of candidates demonstrated the given result correctly. Those candidates who chose to work back often stopped, but they reached the iterative formula, whatever. There were many correct responses. Most errors were due to not working in radians. Some candidates did not work the required degree of accuracy. So now it's 7:32 and we have yes, around like 40 minutes for the other papers. So now I'll just go to the examiner report after going through all these questions, so in order to save time. Now question number 6. Now it says that the diagram shows the curve where a is a positive constant and its maximum point m, so that is the maxima. Find the exact coordinates of m. So this is a question of product rule. So y is equals to x e raised to power of minus ax. And what do we do over here? We have u, we have v, we differentiate. Derivative of u is u prime, derivative of v is v prime. Product rule, uv prime, vu prime. Exponential is always taken common. So exponential is taken common, minus is taken common, and that's how you get this thing. We are looking for the stationary point, dy by dx equals to 0. E raised to any power is never 0. Why? Because e raised to power of x gets very close to the x-axis. This is x-axis, this is y is equals to 0. It does not cut, it does not touch. Ax minus 1 equals to 0, x is 1 over a. When x is 1 over e, we plug in this equation. Instead of x, we have 1 over a. Instead of x, we have 1 over a. And this is getting in the exact form. So it's a pretty basic kind of a question. Just today in the class, we were doing a differentiation and we were working with exponential in ln's, and this e's and ln's, they are part of life. So that's how you do this. The next part. Find the exact value of this integral. The exact value of this integral, that is using this thing. Really need for S2. I have an S2 exam tomorrow. Don't worry, people. Let me tell you again. And there is the S2 paper. That's 9:30 Pakistan Standard Time. So don't worry. All your worries are taken care of. We have a full marathon. It's P3 M1 S2. P3 M1 S2. We are on P3 right now. So now find the exact value of this thing. Now this is integration by parts. So let me just label it over here. This is integration by parts. Now let me write the formula. I do it in a different way. That formula is integral uv u dv, that equals to uv minus integral v du. It's written in the formula booklet. So now what exactly is this? There are two things, they are multiplying together. So first of all, integration by parts is only for a product of two functions. It could be algebra exponential, it could be algebra trig, it could be algebra logs, natural log, that is, it could be simply log into a constant. So these are the different scenarios. And yes, there is the famous one, the exponential and the trig. Now this is algebra, this is exponential. So we have this rule that is saying late, L-A-T-E, that is for choosing u. U is the one that gets differentiated. dv is the one that gets integrated. So what do we do over here? What we do is that u is x, du is 1 dx. dv is e raised to power of negative ax. Integral of exponential remains as it is. Derivative of power comes down and divide. So what is the derivative of this power? Minus ax. The derivative is negative a. Negative 1 over a divides. So the first step is uv. That's u, that's v. That's how I write it. v du. v du, before that there is a negative integral sign. So x into minus 1 over a e raised to power of minus ax. That's the first thing. Now simplification is a must. This negative makes it positive. That's a positive value. This is 1 over a e raised to power of negative ax. And then we have this negative, we have this negative. So what I've done is that out of a and a square, I've taken a common out. Out of this negative and negative, I've taken negative common out. The exponential is taken common out. This is what I'm left with. Now 2 over a is the upper limit, 0 is the lower limit. 2 over a and 0. When we plug in the value, we plug in place of x in place of x. So there are two placements. There are two placements for 0. We simplify. We don't use our sanity in solving these things. So you have to have a very strong control of your nerves. It's not easy. P3 is not for the faint-hearted. If you are doing it, just try to do the things very calmly. I'm not saying that they will give you some extra time, but if you have a correct vision, if you have a correct idea of exactly which technique to be used, for example, in this scenario, if someone uses substitution, they are doomed. You have to use the right terminology. You have to use the right technique. You have to give what the examiner is asking you. And then we end up with this thing, and that's the answer. So now the next one, now it's trigonometry. I'm think I'm just amazed, and how can they give such a simple question? I'm not against you, but I'm just letting you know. I mean, this question is too simple. It says, show that cosine power 4 theta minus sine power 4 theta is cosine 2 theta. So now this is a square minus b square. That is a plus b, a minus b. This is from O-level maths, difference of two squares. And then we have this thing, which is a power 4 minus b power 4. That is a square plus b square. And this is a square minus b square. That is the only logic that applies over here. This is c power 4, c square plus s square, c square minus s square. This is the mother of all identities. This becomes 1. This is the expanded form of cosine 2 theta. Just write it down and you obtain your 3 marks like a king. The next one. It says, hence find the exact value of negative 1 over 8 pi, positive 1 over 8 pi, cosine power 4 theta, sine power 4 theta, 4 sine square theta, cosine square theta. Now, the very first thing that I've done, let me just take this thing from here and let me put it at this corner. And let me draw a box around it. Okay. Now, what I've done is that, first of all, this thing right over here, this thing is like this thing. 4 sine square theta, cosine square theta. So, indices. 4 can be written as 2 square, sine square theta, cosine square theta, and I have taken all the squares common out. So this is 2 square and sine square and cos square, and this is 2 sine theta, cosine theta, the whole thing square. A power m, b power m, c power m, that is a, b, c raised to power of m. That is the logic that's applied. Now we know that sine 2 theta is equals to 2 sine theta cosine theta. Now, people, don't be a slave of your what you call the formula booklet, MF19. These formulas should be handy with you. If you have a habit of flipping on and off, excuse me, if you have a habit of flipping on and off, I mean, you won't get that perfection. Keep that in mind. So now this thing is there. So now let's move on. This thing is replaced. So I have written sine square theta, and how do I get this? Now that is the another thing that I need to explain to you. I've written it very directly. Let me, I think I have to write it somewhere over here. So let me draw a box. So that is cosine 2 theta is 2 cos square theta minus 1. Cosine, and we also have the other format that I need, 1 minus 2 sine square theta. And cosine 4 theta is 1 minus 2 sine square 2 theta. If I make the sine square theta the subject, so sine square 2 theta is half, and this is 1 minus cosine 4 theta. So this is what I've done over here. This is based upon double angle. So I have written it directly without giving you the idea how this thing is formed. And that is how this is done. So now what about this thing? That is, hold for a second, why is it not working? Let me just double check. So now this cosine power 4 theta minus sine power 4 theta. This thing, isn't this the same thing as this thing, cosine 2 theta? This thing is this thing. So this orange one, let me just change over here. This orange or reddish one, that is this. And this bluish one, that is this. That's how the conversion took place. And now it's basic integration. Integral of cosine, let me also write it out. Integral of cosine, let's say 2 theta, that is sine 2 theta, it's positive and it's divided by 2. Integral of cosine 4 theta d theta, that is sine 4 theta divided by 4. So that is the basic idea. Cosine 2 theta, that is sine 2 theta over 2. This is sine 4 theta over 4. This negative sign was already there. Integral of 1 is theta. Constants remain as it is. And then we plug in the value. Now keep in mind, this is 2 theta and 4 theta. That means if theta is pi by 8, if theta is pi by 8, then 2 theta will be pi by 4 and 4 theta will be how much? 4 into pi by 8, that is pi by 2. So therefore, I have written all this thing over here. The working is already done, so we can just pick the things from there. So let me just grab this thing. Okay. So now I have written it over here. This is sine of pi by 4. I plugged in the upper limit, plug in the upper limit, plug in the upper limit at 3 places. Plug in the lower limit at 3 places. These are the exact trig ratios, keeping care of the positive negative sign. Simplify, we have the surds, we have the pi, we have a fraction. So we have surds, we have pi, we have fraction, and this is fully in the exact form. Now let's see, does it ask us to find in the exact form? Yes, exact value. That means it's in the exact form. So that thing is there. And now by this time, you have a pretty good idea that when I say that you have to show all the steps, I mean the magic lies there. Whatever the examiner has written, that is what you call more differentiation of that. That is that read the question, understand the demand of the question, exact form, decimals, work in the right mode, radians, degrees, show every possible step, make a logical conclusion. So everything falls into this category. So now let's look at this question, which is question number 8. It says the points A, B, C have position vectors. OA is this, OB is this, OC is this, where O is the origin. Line L1 passes through B and C. Find the equation for line L1. Now, I think you might have observed that I'm not so picky about how many marks are given and all these things, because if your working is already right, you will be getting the mark. No one is going to sit there in the exam and count, okay, let me do the 1 mark work and let me skip the 2 marks. Of course, no one works like that. So don't be too paranoid about the marks. Just focus on obtaining perfection, show all working clearly, make it a piece of art as the way I have done it, and definitely you will get your score. So now find the equation for line L1. So first of all, it passes through B and C. So either find BC or find CB, doesn't make a difference. So I have found BC, OC minus OB, O-level maths. I get this thing. Since this 3 was common in all, let me take this common out and I get 1, 1 minus 1. Doesn't make a difference whether you use this, doesn't make a difference whether you use it, doesn't make a difference if you simply use this. So I use the simplified form because 1, 1 minus 1, what does it mean? It means go right, go along the x-axis 1 unit, go along the y-axis 1 unit, go along the z-axis negative 1 unit. So 3, 3 and minus 3 means the same thing as 1, 1 minus 1. So direction vector can be reduced. The fixed point, the position vector of the fixed point could be B, could be C. I chose B. Why? Because one of the coordinates is 0. So let's go for the easy thing in life when you can. And what I've done is that I've also expanded and written it right over here because I'll be using it for the next part. That is, the line L2 has this equation, and mu line L2 has this equation. This is the fixed point. This is another parameter. Instead of lambda, they have used mu. Sometimes they use S and T. I prefer the old school variables. That is lambda and mu. I just love them. So now it says find the coordinates of the point of intersection of line L1 and L2. Now, if two lines are intersecting with one another, that means at that point, the x coordinates are the same, the y coordinates are the same, the z coordinates are the same. So now look at the color combo. That is, the x coordinate and the x coordinate should be the same, equation 1, the orange one, equation 2, the dark blue one, or equation 3. So now I'm using the first equation, that is the purple one. So let me just highlight from here. That is the purple one that I formed. And I have used the third equation, which is the dark blue one, because it was easier to evaluate because lambda was already almost the subject. So if lambda is almost the subject, I just change the negative sign on the other side. That is lambda. Plug it in over here. I get mu. I get lambda. So now what did you get? We get mu is 3 and lambda is 2. Now it's your choice. Either place mu where it belongs or lambda where it belongs, you will get the same answer. So I have put in, I think 5 plus 2, I have put it lambda, the value of lambda over here. So let me just pinpoint. Lambda is equals to 2 in equation of line 1. And this is the position vector since they are asking for the coordinates right in the coordinate format. Uh, if they were asking, show that lines intersect, then it's necessary to show that lambda and mu satisfies all three equations. And that is what I've shown over here. All good, all clear? So now let's move on. The next one, the point D. This is also a nice one. The point D on L2 is such that AB is equals to BD. So AB, that is over here. I think this is the working for AB. So let me write over here AB, magnitude of AB. I have OA, I have OB, I find AB, I find the magnitude. So this is step number 1. The next one, BD. So the step number 2 is right over here. It's this flip side. So now in order to find BD, what I do is that I have OD because D is a point on L2. So there is L2. Any point can be written in terms of parameters. So I have just taken that over here and written it like this. What is BD? That's OD minus OB. That's also in terms of this. And if the magnitudes are the same, therefore the formula is x square, y square, z square, the whole thing under root. This is equal to root of 66. And then it's some basic thing, expect the unexpected. Yes, you do get answers like this. So you do get answers like 30 over 7, and then you plug it in, you simplify, either you leave it like this, or you can take 1 over 7 common out, or you can write in the IJK format. This is vector form. Vector form could be the column vector, could be the IJK format. Both are considered correct. So just have a look. They are asking for the position vector. That is why I'm leaving it like this or like this. Over here, they were asking for the coordinates. I got the position vector, but then I wrote it as coordinates. So just fulfill the demand of exactly what they're asking. Now, question number 9. Question number 9 says the complex, this was a good one. The complex numbers z and w are defined by z is 1 minus I. So let me just highlight over here. Z is 1 minus I and w is this thing. Express ZW in this form. So ZW in the form A plus BI, where A and B are real and in exact surd form. So when we multiply, we write Z over here. So let me again use the red marker. So this is Z over here, and this blue one is the other one, which is W. So just look at the working. 1 into -3, 1 into this, -1 into this, minus I into this, and into this. We should know that I square is equals to -1. That is used. So that is why this I square is becoming negative, changing it into positive. So this is the real part, this is the imaginary part, and it's in the exact cert form. That thing is done. The next part. Express z and w in the form rei theta, where r is positive and theta lies between minus pi and pi. Give exact values of r and theta in each case. Now, first of all, when I look at this thing, so z is 1 minus I, 1 is the real part, minus I is the imaginary, it's in the fourth quadrant. We use the positive ratios to find the basic angle. Theta is negative basic angle because it's in the fourth quadrant and we have to go clockwise. Modulus of z, that is 1 square plus 1 square under root. Just take the coefficient, that is root 2. So now this thing over here, hold for a second. This thing over here, this is also known as argument of z or theta, and this is known as r. R is modulus of z. So this is r e I theta. That is how I have written z. Okay. Over here, -3 plus 3 root 3i. This is -3. This is positive. It's in the second quadrant. Basic angle is obtained using the positive ratios. It comes out to be pi by 3. So this is pi by 3. This is anti-clockwise. This is second quadrant. This is pi minus pi by 3, which is 2 pi by 3. Magnitude of W is coming out to be exact 6, and that is how this is written. So now it's using the trigonometric form of the complex number. All good. The first one was multiplication based upon the Cartesian form. The second one was the trig form. The third one, now this is a good one. It says on an Argand diagram, the point representing W. W is this blue colored thing. Okay? But over here it's some other color, doesn't make a difference. So W is what? That is this thing, -3 plus 3 root 3i. So this is W. Let me highlight it. -3 and 3 root 3i. This is denoted by A. So W is A and B is ZW. So ZW is right over here. That is 3 root 3 minus 3 and 3 root 3 plus 3i. 3 root 3 minus 3, that's right over here, and 3 root 3 plus I, that's right over here. So this is A, this is B. Magnitude of OA, magnitude of W was already given as 6 units. And OB over here, that's 3 root 3 minus 3 whole square, 3 root 3 plus 3 whole square. That is a big stuff. So this is a square minus 2ab plus b square, a square minus 2ab plus b square. This is a square minus 2ab, this is a square plus 2ab. Okay? And then you simplify and simplify and simplify, and this comes out to be 6 root 2 units. And the third thing, that is this thing, that is AB. What is AB? OB minus OA. You get this thing. And the magnitude is coming out to be 6 units. This is what the examiner was pinpointing towards. That is, since AB is equals to OB, the triangle is isosceles. And we also have to prove that this is a right angle triangle where O is the origin. So what I've done is that I've just used a very simple rule, nothing special, that is cosine rule. So now the diagram is not drawn to scale. This is the biggest length. This is the hypotenuse. So therefore, I can use the Pythagoras theorem. I use cosine rule. It just clicked to me. I could have used the Pythagoras theorem also. 6 root 2 whole square. Is it equal to 6 square plus 6 square? Yes. So this is 36 into 2. That is 36 plus 36. Yes, it's equal. It fulfills Pythagoras theorem. Now, sometimes you are so thinking on a different level that I went ahead and used the cosine rule. That is perfectly fine. So basically, there are two ways that I did. The first one is cosine. The second one is Pythagoras. So over here, this is 6 root 2 whole square. That is 6 square plus 6 square minus 2ab cosine theta. Since this is 0, Cosine of theta is 0 means theta is 90 degrees. So this is also good. This is also good. Naturally, this is shorter and sweeter. Now, this one was a very nice one. That is, use your answer to part B. Prove that tangent of 5 over 12 pi is this much. Now, part B is this thing. There was part A, then there is part B. Now, in part B, what do I have? I have modulus of z. I have the argument of z. I have the modulus of w. I have the argument of w. And they are asking us prove that tan of 5 over 12 pi. Now, what I did is that I simply wrote it. I simply wrote argument of z. I wrote argument of w. I said, let's add it up. And what I get is 5 pi over 12. Oh, then I realized this is 5 pi over 12 by addition of two arguments. If these angles are adding up, isn't that equal to argument of zw? That's argument of z plus argument of w. That is 5 pi by 12. Also, did the examiner made me evaluate ZW? So it's not just related to part B, it's also related to part A, but they have not written it. They are leaving something for your intellect also. So therefore, for part A, ZW, this is the whole thing. Let me simplify. So therefore, I'm writing ZW is this thing. And let me write this I over here. So this is the real part. This is the imaginary part. Argument of this thing is tan inverse of imaginary over real. Now, both these values are in the first quadrant. So therefore, the basic angle is the principal argument, theta is alpha. So therefore, I just simplified it. What I did is that I took common, it cancels out and we get this. So argument of ZW is already given as 5 pi by 12. Argument of ZW from over here should also be there. So this argument is tan inverse of this thing. In other words, tangent of 5 pi by 12 is this. So a very classical question, not for the faint-hearted. Definitely it's not for the faint-hearted. And let's move to the next part. By writing y is equals to sec cube theta as 1 over cosine cube theta, show that. So y is 1 over cosine cube theta. I've written as cosine theta raised to power of 3. Let me take it up. Cosine theta raised to power of negative 3. Let me apply chain rule over here. So this application over here of differentiation, this is through chain rule of differentiation. What it says is this. Take the power down. Bracket remains as it is. Power reduces by 1. Don't forget to multiply by derivative of bracket. And then you get this answer. Now, for the next part, later on, what I've done is that if derivative of this thing is this, therefore integral of 3 sine theta over cosine power 4 theta is 1 over cos cube theta. Because differentiation, integration, they are reversible. Now it says the variables x and theta satisfy the differential equation x squared plus 9 sine theta d theta over dx x plus 3 cosine power 4 theta. It is given that x is 3 when theta is pi by 3. Solve the differential equation and we will consider the rest of the part later on. The first thing, d theta is in the numerator. Take the theta to the other side. Sine theta over cosine power 4 theta. That is the first step. Take this x squared over 9 on this side, x plus 3 over x squared plus 9. Now over here, we have this thing that is 3 times sine theta over cosine power 4 theta. So what I did is that I multiplied both sides by 3. This is 3 sine theta over cosine power 4 theta, 3 into x, 3x, 3 into 3 is 9. Now split right hand side. So this is 3x over x squared plus 9. This is 9 over x squared plus 9. A very, very classical question. Now over here, this thing over here, this integral is 1 over cos cube. You don't have to do it. You cannot do it because it's beyond the scope of the syllabus. But they have given you a hint. Derivative of a, if it equals to b, integral of b equals to a. So integral of this thing is right over here. Over here, we are using this thing. If the numerator is derivative of denominator, then the integral is ln of denominator. So the 2 was missing because x squared, the derivative is 2x. Since you multiplied by 2, you should divide by 2. This whole thing disappears and instead of this, what appears? That is ln x squared plus 9. So this is ln x squared plus 9. That is right over here. Over here, the next thing, we have this thing which is 9 over x squared plus 9. Keep the 9 on the outside. X squared plus 9 can be written as 1 over x squared plus 3 square. It falls into this category. If you get an integral like this is not partial fraction. Keep that in mind. This is 1 over a tan inverse x over a. So this is a square. This is x square. So this is 9 as it is. 1 over 3 tan inverse x over 3 plus c. So now the orange part is right over here. This is 3. And let me just choose the orange part. That is right over here. Tan inverse x over 3. That's how this is done. And then plug in x is equals to 3 when theta is pi by 3. So we plugged in over here. We plugged x is equals to 3 over here. We plugged x is equals to 3 over here. And we simplified and we get this long thing which is right over here, which is, let me highlight it, that is c equals to 8 minus 3 over 2 ln 18 minus 3 pi by 4. So again, what do we have? We have number, integer, we have ln, we have pi, and so on. And last but not the least. So now over here, let me write it. This is 8, 3 over 2 ln 18 minus 3 pi over 4. So this whole thing is c. And what is this equal to? This is equals to 1 over cos cube theta. That is 3 over 2 ln 9 minus 3 tan inverse 0. What are we plugging in? We are plugging in, solve the differential equation, find the value of cosine theta. We are not finding the angle, we are finding cosine theta when x is equals to 0. So now let me write it. Now plug in x is equals to 0 and we solve and we get this answer. And that completes the paper. So that was all about it. And I think you have enjoyed this session. So I'll soon be starting the other thing. We have a few minutes. Let me just go over this thing. And over here, I think worthwhile was this question, which is question number 9, which is complex number. So let me just focus on complex numbers. It says the majority of candidates scored the mark for this part. That was ZW. There were several slips in the arithmetic and some candidates did not present the answer in the required form. If they are asking the answer in the form A plus BI, we have to give in this form. We have to give the answer in the exact form. The omission of brackets. Okay, I think it's a worldwide phenomena, that is omission of brackets. Somebody asked this question, any predictions for paper 32? I think you cannot predict a paper. This is not Pakistan studies or Urdu or Islamiyat, something like that. Yes, you can just give an idea based upon the number pattern that since such a question would come, something might be there. So let's see if it occurs to me, if I get that inside thing like that, and maybe I can share it later. At this moment, none. So now the next one, it says the question set requires 4 values in the answer, 2 moduli, 2 argument. The candidate who did this usually scored the 2 marks for the moduli. The arguments were more difficult because thought had to be given to the correct quadrant. I like this. Thought had to be given to the correct quadrant. I mean, this examiner, whoever that person is, I think that's the most blunt kind of examiner report that I've ever seen. Maybe he's a person who's studying English literature, but the way that he has expressed it, I mean, he has shared my feelings with you. That is, please, please, please read the question, follow the instructions, so that you are able to be successful in that particular paper. It was common for candidates to give the modulus and argument of ZW, and none of these values were required by the question. No one was asking for that. Third part, the question requires a proof. Both aspects, the isosceles triangle and the right angle triangle, need to be addressed. Some candidates did set out with the correct approach, considering the lengths of the side of the triangle as it is part of a proof. Sufficient working needs to be shown to confirm how the lengths were obtained. For OB and OA, this can come from the work in part B. Some candidates established that OA is equals to AB but made no comment. How can you establish a fact without giving a proof? Having found the lengths of all three sides, the simplest way to demonstrate the right angle triangle is to use Pythagoras, but again, an appropriate comment is required. It follows Pythagoras theorem, it's a right angle triangle. Some candidates were successful in using gradients to demonstrate a right angle triangle. Not bad, not bad. A minority of candidates created a circular argument, assuming that there was a right angle in order to show there was a right angle. I mean, I don't want to say anything about it. Although not required, many candidates drew a sketch. No, I won't agree with this part. I think sketch makes you think clearer. That clarity of vision is needed, so draw a sketch. Many of these sketches did not show anything that looked like a correct triangle. I mean, that I can agree with that. As long as you know where you have to go, that makes sense. The evidence for a correct solution should come from the correct use of the arguments found in part and the product of this thing. Very few responses gave a correct proof. The majority never mentioned that they were using argument of z and the general result for the argument for a product. Yes, we did mention it. So at this point, the marathon, we are taking a pause. So now P3 is all done and dusted. And in few minutes, we'll be starting with M1. So take care, everyone. And there's some people, I'll be seeing you in the other class. So I think that's the one that I should press, returning shortly. I think it's on. Okay. Hello, everyone. Welcome to the Math Marathon. The P3 session is over now. That was a wonderful session going over the first paper and going through the examiner report and things like that. The same pattern will be followed in M1. M1 stands for mechanics, and of course, you know mechanics in and out. The main topics that we focus on is that we focus on everything. There is nothing in mechanics that you can take for granted, whether it's kinematics, with variable acceleration, which is related to differentiation and integration, and so on. So that thing is there. And of course, we have laws of motion, we have connected particles, work energy power, momentum, friction, resolution of forces, equilibrium of forces, and so on. So the paper that I'll just share over here, let me go to the main thing. That is this one. And we'll be starting with this particular paper. So let's get started with this. So this is the paper for May-June 2024, variant 42. I found this paper to be nice, and there were some questions that were kind of like crazy kind of question. So let's see how it goes. So this is the second variant, and let's get right to it. Now, first of all, what I'll do is that I'll go over the whole paper, and then I'll go to the examiner report, so that even if there is a shortage of time or some instructions that I need to give to you, so we can use the time very wisely. Now, the question says a cyclist and a bicycle have a total mass of 72 kg. The cyclist rides along the horizontal road against a total resistance of 28 Newton. Find the total work done by the cyclist to increase the speed from 8 to 16 while traveling a distance of 100 meters. So now what are the things that we need to focus on? We need to focus on, first of all, it's a horizontal road, the mass, the resistive force, the distance, the change in speed. So now what I've done is that, first of all, when the speed increases, that means the kinetic energy increases. So change in kinetic energy is positive, half m. This is v square minus u square. So therefore, this is positive. Use exact value, do not round off. Change in potential is 0. Why? Because this is a horizontal road. There is no change in height. So that is the basic logic that is applied over here. Work done against resistance. So we are focusing on change in kinetic energy, change in potential energy, work done against resistance. That is resistive force into the distance that it travels. And the last but not the least, that is work done by the cyclist. That is change in kinetic, change in potential, work done against resistance. You just add it all up and you get this answer. Very simple, basic question. The second question, that is about differentiation and integration. So let me just highlight this over here, right? Let me write it like this over here. The first one is the work energy principle, and I think they just had a little bit more of work and all these things in this particular question. So now over here, uh, the next question, that is about what? That is about kinematics, and I refer to this thing as kinematics 2.0, because this kinematics is about differentiation and this kinematics is about integration and so on. So now the question says a particle P moves in a straight line at time t seconds after leaving a point O on the line. P has a velocity v, where v is this much. So that is the velocity equation that we have. The first part, find the set of values of t for which the acceleration of the particle is positive. So now what should be in your mind? The first thing is that the derivative of displacement is velocity. The derivative of velocity is acceleration. So the very first thing that I get started with is this thing. That is over here. I'll say v is given as this. Therefore, a is dv by dt. We just differentiate and we get this thing. A is positive. That means a is greater than 0. So 44 minus 12t is greater than 0. Therefore, t is lesser than 11 over 3. It's a simple linear inequality. Now remember, when we give the paper of M1, M1 is associated with P1. A person doing P1 can give M1, a person doing P3 can give M1, people can also give composite. That means all four papers. So the level of algebra that they will ask will be based upon the P1 level. Whether it is about quadratics, it's about increasing, decreasing functions. Sometimes they can ask about completing the square, some concept of quadratics, and so on. Find the two values of t for which p returns to O. So if p returns to O, that means the displacement is 0. But before that, we need the displacement expression. So in order to find the displacement expression, what do? We have this thing, s is equals to the velocity equation, and we will integrate it term by term. So when we will integrate it term by term, that is 44t, 44 44t minus 60 square minus 36, 44t minus 60 square minus 36. This t becomes t square over 2. This t square becomes t cube over 3. This constant gets a t attached to it. And 44 over 2, that's 22. 3 ones are 3 twos are, and this thing, and you have a constant of integration c. Now, how did I get this thing? That is t is 0, s is 0. Where did I obtain this? I obtained this from here. It says when it is leaving a point O on the line, that means initially. So let me write over here, initially, displacement is 0. So initially means t is 0, s is 0. That is what I'm using over here. So when t is 0, s is 0. Therefore, this, and this cancels out. Therefore, c comes out to be 0. You cannot just take for granted. You have to, what you call, justify every single thing. So now over here, when s is 0, therefore, this expression over here, let me highlight this. This expression over here, we make it equal to 0. This is a cubic expression, but there are no constant terms, so keep that in mind. And now they have put something like this in O-level syllabus also. A cubic with no constant term, so you can take the t common out and it becomes quadratic on the inside. So that's a quadratic on the inside. There is a t on the outside. T is equals to 0. That is the beginning of time. That is the beginning of the journey. And what else have I done? I have taken this -2 also common out. And then I have this quadratic thing. I fit middle term factorization. I get t is equals to 2, t is equals to 9. So it says find the two values of t at which p returns to 0, because initially it was at the origin. At the origin, and at time t is equals to 0, it's back at O. At time t is equals to 9, it's back in O. And I can write seconds over here. Uh, let's see how it goes. Maybe if there is time left, we can just go over some other ideas also. This is in reference to someone who just asked this question. Sir, will we do just one paper? Let's see how it goes. Question number 3. Question number 3, this is about this thing. So that is the concept of resolution of forces. Now let me just do one thing. Let me just add a page over here so that first of all, you can look at the question without looking at the answer. So if I look at this question, the question says 4 coplanar forces of magnitude. This thing is P. Where is P? There's P, and then there is 10, and then there is 16, and there is 2. So we are going clockwise in this direction. They act at a point as shown in the diagram. It is given that the forces are in equilibrium. Find the values of theta and P. Now the rule is any force which is at an angle needs to be resolved. So 10 Newton, it's at an angle of 25 degrees. 2 Newton, it's an angle of 40 degrees with the horizontal. But 16 Newton, it's an angle of theta with the horizontal. So what I'll do is that the first thing that I'll do is that theta 16 Newton, it's an angle of beta degrees with the horizontal. So I'll first focus in terms of beta, and then I'll find theta. Now, why do I do that? I do that for you people. That is so that you have an ease of thinking all the horizontal components with respect to the horizontal. will have a cosine in it. So now remember this rule that we have done in class. Those who have studied with me, they know this, what I'm talking about. That is, if, let me just correct this thing. Let me make it straight because if the line is not straight, I won't feel comfortable. So let me just remove this thing like this. Now the rule is, hold for a second. This is if, this is theta, this is A, this is B. So sine theta is A over F, therefore A is F sine theta. And cosine theta is B over F, therefore B is F cosine theta. The vertical is always associated with sine, and the horizontal is always associated with cos, provided this angle is with horizontal. So that is the logic that I apply for simplicity. It's not a matter of right and wrong. S2 will be at what time? S2, I think it is, let me just check my phone. I think it is at 9:30. So over here, yes, S2 is at 9:30. So I'm just looking at this image. I think if you can see comfortably. So that image of Alt Academy, S2 at 9:30. Okay, so now coming back to this. Now I'll be working. I've already worked it out. I'll just show you the working. So now over here, look at the working. The working is P needs no resolution as it is. 10 Newton horizontal component, 10 cos 25. Vertical component, 10 sin 25. This 16 Newton over here, this angle is beta, which I've labeled over there. So I'm working in terms of beta. Theta plus beta is 90. Once I find beta, I'll subtract it from 90. So now this is 16 cosine beta. Again, the horizontal has cosine. The vertical has sine. This is 2 Newton over here. The horizontal component is 2 cosine 40. The vertical component is 2 sine 40. So now, since it's in equilibrium, just have a good look at it. Okay, so that is the upward force equals to the downward force and the downward force and the downward force. So this plus this plus this is equals to P. Similarly, the rightward force, that's only one of them, equals to the left and the left. So now let me write it down. So first of all, 10 cos 25, that is this one. So this is 10 cos 25, the orange one. Let me highlight 10. Let me make it thicker. 10 cos 25, that is this thing, should equal the blue one, which is 2 cos 40, which is 2 cos 40 plus 16 cosine beta, 16 cosine beta. That is equation number 1. I hope you can see all the colors over there carefully. Okay, the next one, P, that is the purple one. So P is this purple one. P is up. What is it equal to? It's equals to 10 sine 25. So this is over here. This is 10 sine 25. That's going down. The green one is 16 sine beta. The green one is 16 sine beta. Let me also put the orange one. 10 sine 25, and what is left? And the blue one, which is 2 sine 40, and the blue one, which is 2 sine 40. So now take your time in forming these equations, because these equations will ensure that the rest of the working is correct. Now I've seen people who are in a bit of a hurry, who think that let's just form the equation, we will double check it later. But you are creating a mess for yourself. And we will go to the examiner report, and the examiner will exactly amplify what my thoughts are. That is, read the question carefully, show all the working, think over each and every step, understand what the examiner is asking, and then answer it. So now what I've done is that I have taken the data from this thing. That is the diagram. I have done one improvisation, that is introducing a new angle beta, because I don't feel comfortable working with theta with the vertical. I love angles which are with the horizontal. So I'll work in terms of beta, and I'll make beta the subject. That will be 90 minus theta. Then I've done all the resolutions, as you can see, very, very colorfully, Instagrammable stuff. And then after this is done, then right equals to left and left, up equals to down, down, down. From over here, now it's time to do the messy stuff. That is the calculator thing. 10 cos 25, use a calculator. 2 cos 40, make sure the calculator is in the degree mode. 16 cos beta, so make cos beta the subject. You'll find beta, that is 61.92. And this is for the later stage, that is theta plus beta is 90, therefore theta is 28.1. This is for later. For right now, I'll be needing this on the other side. So let me plug in beta over here. Let me plug in beta over here. This is 2 decimal place value. So work in 2 decimal places so that the final answer is 1 dp. And then we find the value of P, and the value of P comes out to be 19.6 Newton. So decimal place 1 dp, everything else 3 SF. So I think this question number 3 is all done and dusted. Now, let me just add a page first. No, actually, I've done this. Oh, that was the next page. So hold for a second. This thing is done. So let me just remove these two. And this is good. Okay. So now question number 5. Let me add a page over here. Let me first explain this question. And then after 5 questions, I'll go to the examiner report first. Now, first have a good look at the question. It says there is an inclined plane that you see. I want you to first focus on the diagram. Let me just remove my picture so that you can clearly focus on the diagram a bit more. So I'm just turning the camera off so you can comfortably focus. Now it says a particle of mass 0.8 kg lies on a rough plane which is inclined at 28 degrees to the horizontal. So now the first thing that they're focusing on is this 28 degrees, and that's the weight. So that is mass of 0.8 kg, and it's a rough plane inclined 28 degrees to the horizontal. The particle is kept in equilibrium by a force of magnitude T Newton. It's a force. The force acts an angle 35 degrees above the line of greatest slope on the plane. So this is the force T, and this is 35 degrees that we are working with. 0.8 kg, that was already there in the beginning. Now it says the coefficient of friction between the particle and this thing. So coefficient of friction between the particle and the plane is 0.2. Find the least and greatest possible values of T. So now what you see over here is that you are working. Let me turn the camera on. So now the diagram is done. I think mean. Okay, now this is the one. Okay, now I'm back. So now the concept is that we have this thing, and let me just prove this thing on the side. That looks good. Okay. And what we see over here is that there are technically 2 inclines. The first incline is this thing, and the second incline is this thing. Now, what do we need to consider? We need to consider that this T needs resolution. So this is again with the horizontal. This is T cos 35. This is T sine 35. That's the first thing. Make sure you mark the normal reaction force. Make sure you mark the weight component. This is mg sine theta. This is mg cosine theta. And now comes the rough part, the rough plane. That is, if the particle is about to move up, then friction is down. Or the particle is about to move down, therefore friction is up. Friction always opposes motion. Let me write it down. So friction, 2 things about friction. Always opposes motion. And the next thing, that is friction always acts parallel to the surface. Parallel to the surface. All good? All clear? Now, keeping this in mind, this is for 8 marks. It's not difficult, it's lengthy. Now you have the mind made up. Now let's look at the diagram. Now, this is the diagram that you see over here. Again, I'm just removing my picture so you can focus on the diagram. So now we have the normal reaction force, which is R, the components of T, T cosine, T sine, based upon this angle 35. Weight component down the plane, mg sine theta. It's a weight. So g has to be there. The value of g is 10 meter per second square. And this is mg cosine theta. I have deliberately not put the friction over here. That I'll do separately. Now, before that, what is the first thing that I've done? I have found the value of r in terms of t. I have found the value of f max in terms of t with a lot of messy decibels. So over here, r is going up, t sine 35 is going up, 0.8 g cosine 28 is going down. So r is this weight component, the cosine component, minus the t sine component. And f max is mu r. So again, have a look. R plus t sine 35 is mg cosine 28 degrees. R is this value is a decimal. I'm working in 4SF, and this is 1, 2, 3, 4SF, and there is a t over here. F max is mu r, so just take this, multiply by 0.2. Just take this, multiply by 0.2, and this is what you get. That is the first thing. So maybe 1 mark for this one, 1 mark for this one, and let's work out the rest. When the particle is about to move up, F max is down. So if F max is down, that means F max, which you have already calculated in terms of t, plus mg sine theta equals to t cos 35. And let's say the particle is about to move down, therefore F max is up. So therefore t cos 35 plus F max is mg sine theta. Now just have a good look. First thing first. About to move up, F max is down. So F max plus the weight component down the plane is equals to the tension component up the plane. So now you work it out. What is the strategy? The strategy is make T the subject. So now over here, if I make T the subject, that is this thing, and this thing is over here. So there is a T over here, there is a T over here, and then you work it out. Over here, what am I looking for? I am looking for the maximum, greatest and least possible values of t. So now this thing is incomplete. Let me grab my calculator. I can just complete it right now. Totally slipped. So therefore, let me get a basic calculator. And now this is 0.8 into 10. 0.8 into 10. That is definitely 8 into sine of 28. No, I need this thing. So first of all, I need a scientific calculator. So this is 0.8 into 10 into sine of 28. It's in degree form, sine of 28 degrees, plus, no, not over here. Let me go back. Bracket closed, equals to. So this is 3.755, 3.755 or 6. One more back. Plus 1.4128 divided by 0.11472 plus cosine of 35. Let me write 35. Let me take cosine. This comes out to be 0.819. 0.8192, and this is t. So that is one value. And the other value that's right over here, that is 0.8g sine 28. I think I already have that. This is 3.5, 3.756. This is 7, this is 5, this is 6. That's right over here. Minus 1.4128 divided by cos of 35 is 0.8192. This is 0.8192 minus 0.11472. This is equals to the other t. One of them will give you the maximum value, the other one will give you the least value. So now I'm just going to the basic calculator. So first of all, 3.576, 576 plus 1.4128. And this is divided by inside a bracket. I cannot put a bracket over here. Scientific, and where is the bracket? There, it's the bracket. 0.11472 plus 0.8192. 0.8192. Let me close the bracket and evaluate. This comes out to be 5.34. So T comes out to be 5.341342. So I think this is 5.34 Newton. This is one value. The next value are 3.576. So let me just divide. Let me put a bracket. 3.576 plus minus 1.4128, 1.4128, close the bracket. It's not a touch screen. 3.576 minus 1.4128, close the bracket. 1.4128. Okay, all good. And the bracket is closed. Then the division sign, then another bracket. This is 0.8192 minus 0.11472. 0.11472. Let's close the bracket and equal. This comes out to be T is equals to 3.07 Newton. So therefore, this one is the least value. This one is the maximum or the greatest value. Instead of max, let me write greatest. So that means a greatest value will occur when the particle is about to move up, and the least value will occur when a particle is about to move down. So let me just check the working for this. And this is M1. And this is which question? This is question number 5. So let me look at question number 5. That's right over here. 5.53, 3.33. Okay, maybe there is some arithmetic error that I've done. So just get it corrected. And because I'm just using the phone calculator, so just get the thing correct. So that's how this thing is done, because maybe in one of the place I was unable to get the whole thing correctly. So let me just remove this thing, and let me just write that you just have to make T the subject. Rest of the working is all good, all correct. So let me go to the main thing, and I'm back on the screen. So now we have done 5 questions. Question number 5, that is about friction, and it's on inclined plane. The question number, okay, that is friction on the inclined plane. Did I skip question 4? I think I skipped question number 4. So let me just go over that. This is power. So question number 4 is about power. Question number 3 is about resolution, equilibrium. Question number 2 is about kinematics, that's labeled, and question 1 is work energy principle. So now let's look at question number 4. Now question number 4, it says a car has a mass 1400 kg, and when the speed of the car is v meter per second, the magnitude of the resistance to motion is kv square, where k is a constant. The car moves at a constant speed of 24 meter per second and up a hill at an angle of alpha to the horizontal, where sine alpha is 0.12. At this speed, the magnitude of the resistance is 480. Find the value of k. So this is the magnitude of resistance. This is the magnitude of resistance. kV square is the resistive force. This is 24. That goes over here. This is 480. Simplify. K comes out to be 5/6. I think that is pretty basic. The next thing, find the power of the car's engine. Now, it's moving at 24 meters per second and constant speed. Therefore, acceleration is 0. Power over velocity, that is the forward force pulling it. Resistive force is slowing it down. Weight component is slowing it down. So since the acceleration is 0, therefore the upward force and the downward forces are equal. So therefore, P over V is RF plus mg sine alpha. So P over V, which is 24, this is RF, which is 480, and mg sine alpha. Instead of the angle, they have given us the exact ratio, which is 0.12. Therefore, P comes out to be this value. I can even write this thing in kilowatts, and that is the exact value. No need to round off. The car now moves at a constant speed on a straight level road. Given that the engine is working as 54 kilowatt, find the speed. So now again, constant speed, we don't know what's the speed, so let it be v. 54 kilowatts, that's 54 into 1000, that's the forward force. kV square is the backward force. So we have this 54,000 over V is 5 over 6 V square. Looks like a scary equation, but it's not. It's just a cube thing. V cube is this much. Therefore, V is 40.2. Correct to 3 is if. Just have a quick look at the M1 examiner report based upon the first 5 questions. So now it says the inclusion of a well annotated diagram, force diagram, has improved when answering the question involving any system of forces. So inclusion, well annotated force diagram, improved when answering questions, whether an equilibrium situation or when using Newton's second law. Such a diagram would be particularly useful in question 5 and question 7a. We'll soon be there in 6 and 7. Momentum questions would benefit from diagrams. I always believe in drawing diagram. I do that. Showing speeds and directions before and after collision to ensure signs error are eradicated when forming momentum equations. Very, very necessary. Non-exact numerical answers are required correct to 3 significant figures as stated on the question paper. Candidates would be advised to carry out all working to at least 4 significant figures. That's at least. And if a final answer is required, to 3 is if. That is basic. Only when rounding off is required, that's when you worry about the accuracy. Questions 1, 2a, 4a part 1, 4a part 2 have exact answers. It should be noted that only non-exact answers should be approximated. Exactly what I told you. So these answers do not need to be given to 3 significant figures. That is the key message. Now let's go back to the paper. That is question number 6 that's coming up. Okay. Now, this is a very strong question. So, the last 2 questions, yes, they do take time. So, what is your strategy? Your strategy is the first 45 minutes, you should be done with 5 questions, last 30 minutes for 2 questions. That is the normal rule, whether it's M1, S1, or S2. Now, it says 3 particles, and I've colored it A, B, C, red and blue and green, of masses 5, 1, 2, respectively, lie in that order on a straight, smooth, horizontal track XYZ. Initially, A is at X, B is at Y, A is at X, B is at Y, C is at Z. Particle A is projected towards B with a speed of 6. Now they all are at rest. So this is at rest. So let me write just thing over here. This is initially at rest. Particle A is projected towards B with a speed of 6 meters per second. And at the same instant, C is projected towards B. So C is going this way with a speed of V meter per second. In the subsequent motion, A collides and coalesces with B to form particle D. So there is A, there is B, there is C. These two will join together and it will form a new particle D. That is step 2. Particle D then collides and coalesces with C. So now D is moving ahead and C is coming this way. So let me just draw C this way. So you can see that C is still there. So C is coming this way with the speed of V meter per second. It will collide and it will form a new particle. So D and C collide. And what is the name of the new particle? That is E. And E moves towards Z. So there is so much scenario in this particular question. So there is so much variety of it. So now what is it asking? Show that after the second collision, the speed of E is this much for 3 marks. Now, sometimes even a difficult question has lesser marks. Sometimes even a easy thing has more marks. So there is no set rule as such. So now over here, what I'll do is that let me write this. That is step number 1. First, deal with this 2 scenario. That is 5. The mass is 5 into 6 plus whatever the mass, 1 into 0. This is before collision. After collision, they become 1. So 5 plus 1 is 6, 6 into W. So W comes out to be 5 meter per second. This W is the speed of which particle? This is speed of particle D. So now this D is traveling with W and the value of W is 6 meters per second. My bad. Let me get some water. So now this is 6 meters per second, and this C is approaching this thing. So now the next step, 6 into 5, this 6 into 5. So my bad, this is 5 meter per second. I'm just mixing up the two. Hold for a second. This is W. The value of W is 5 meter per second, and this is 5 kg plus 1 kg, that is 6 kg. And C is how much? C is 2 kg. So now the working is this: 6 into 5 plus 2 into V, but we are taking V to be negative. Why? Because it's traveling in the opposite direction. That is equals to 6 plus 2, this is 8. So now this is 8 kg and it's moving at K. So therefore, 6 into 5 is 30, 2 into negative V is negative 2V, 8K is over there, make K the subject, simplify, and we get this answer, that is for 3 mark. So I hope everyone who's watching over here, they are understanding the very first part. Now look at the beautiful diagrams that needs to be drawn. Of course, I know it's not an art paper. You cannot draw colorful diagrams in the exam, but you definitely have to draw. And I just read it out what the examiner expects of you, that small diagrams are a must. Because if you don't draw these diagrams, how will you have a clear idea? Now, first of all, tell me, do you see any use of calculator over here? I don't think so. So when you're not using a calculator, then keep the calculator aside, focus on the scenario, because these diagrams will help you in the later part. Now the next one. The next one says the total loss of kinetic energy of the system due to the two collisions is 63 joules. Use the result from part A to show that V is equals to 3. So kinetic energy initial, that is the kinetic energy of particle A and the kinetic energy of particle C. So let me label it. So A is this thing, that is kinetic energy of particle A, kinetic energy of particle C. So this is for particle A, this is for particle C, that is 90 plus V square. The final kinetic energy, that is A plus B plus C. So let me write it over here. That is A, and this is B, and this is C, that is particle E actually. So this A plus B plus C, this becomes E. So that is half into this thing, half into 8 into this thing, the speed square. This speed, which I've labeled as K, this is 15 minus V over 4. So this is 15 minus V over 4, the whole thing square. Expand, simplify. And then we have this V over here, equate, simplify, O-level maths, simplification, factorization, quadratic formula. If the numbers are too large, we get the answer as 18 over 6, which comes out to be 3 meter per second. Just have a good look at it. So kinetic energy initial, that is the kinetic energy of A and the kinetic energy of C. Kinetic energy final, that is A plus B plus C. So I don't understand this part B. What about the kinetic energy? Why don't we consider B as well? Look, there are intermediate steps over there. And in mechanics, there are more than one ways of achieving a thing. So what we do is that we consider B. First of all, why are we not considering B? Because it was initially at rest. So that is 0. Initially, at the beginning of the journey, what is happening? There are two particles, they are moving, right? That is the initial. Finally, whatever has happened, that they become A plus B plus C, that is E. So just take the initial, just take the final, subtract, equate, and then you get the answer. Now over here, this next part was a classic. Whether it's C part 1 or C part 2, that is 5 marks. I think it's worth much more than that. Now it says it is given that xy is 36 meter and the distance yz is 98. Now what is happening? First A was there, B was in the middle, and C was moving towards each other. Now keep all these things in mind. And now let's see what happens. A and B coalesce, becomes D. D and C, I think they meet and they become E. Okay. So now the first scenario, find the time between the collisions. This distance xy is 36. So this is 36 and this is, I think, 98. That's right over here. Now the first step, step 1, that is it's traveling at a constant speed of 6 meter per second. The distance is 36. 36 divided by 6, that comes out to be 6 seconds. I have written the full formula, s is equals to ut plus half at square, but since acceleration is 0, this part is 0. So therefore, we are left with s is equals to ut, and we get 6 seconds. So this is 6 seconds before A and B coalesce. Now, in these 6 seconds, what is happening to V? V is also traveling. So now in these 6 seconds, it's traveling at 3 meter per second. That was the value of V. So now let me just show you so that you don't get confused. So C had a value of V, and the value of V from the second part comes out to be 3 meter per second. And keep in mind the value of E, the speed of E, that is 15 minus 3 over 4, which is 12 over 4, which is also 3 meter per second. So now these are the speeds that we are considering. Coming back to this. Step 2. So now C is traveling at 3 meter per second. In 6 seconds, it will travel 18 meters. Now, what is happening? The distance remaining, step number 3, that is 98 minus 18 for C. So this is Z somewhere over here. Somewhere over here is Z. It has traveled 18 meters. And how many meters are left? 80 meters. Now A and B coalesce and form particle D traveling at 5 meter per second. Again, this value is from the first part. C is traveling at 3 meter per second. Now over here, since we are not dealing with momentum, we don't take the negative sign of the negative value of V. We don't give it a negative notation. No, because we are not dealing momentum. Basically, what we do is that there is a time period such that 5 times t, the displacement of D plus the displacement of C should add up to 80. They are traveling 5 meter per second. Every second, it will be traveling 5 meters. So for time t, it will be traveling 5t. This particle C over here, this is also traveling at 3 meter per second. Every second, it will travel 3 meter. Every t second, it will travel 3t meters. So now 5t plus 3t is 8t. Therefore, t comes out to be 10 seconds. Find the time between the two collisions. So now that thing is done. So this time between the two collisions is this, because this was the first collision and the second collision is about to happen. That is 10 seconds. Now, what do you think is the next part they're asking? Find the time between the instant A is projected from X and the instant E reaches Z. Now, it's the total time of the journey. First of all, this 6 meter per second was given. That is, yeah, 6 meter per second. That was 36 meter. So first 6 seconds are there. So let me highlight this thing. So that is first 6 seconds are there. A travels 36 meters, C travels 18 meters. Now, what is happening in stage 2? So now in stage 2, A and B collide and coalesce with C. A and B collide and coalesce with C, and it took 10 seconds. That means out of these 80 meters, it was 80 meters like this, okay, before the coalesce. So let me just remove this 80 from here, and that's a stroke eraser. Okay, so now over here, this thing was 80 meters. So now out of these 80 meters, A and B travels 5 into 10, 50 meters before collision. And if you want, I can write C travels 3 into 10, which is 30 meters before colliding. Okay. But I'm looking from the perspective of D. This is D. Why? Because it has to travel all the way till C. So now out of this 80 meter traveling that's done, 50 meters is already covered. So 98 minus 50, I have not written this. So 98 minus 50 is 48. That needs to be covered. And that will be covered at which speed? That will be covered at 3 meter per second, because the value of K is 3 meter per second. Now this is a bit, what you call, claustrophobic kind of thing. So let's just have a look at it again. Find the time between the instant, and they're just giving us 1 mark. I mean, it's not worth 1 mark because you just have to connect the dots. Yes, you don't have to do that much of calculation, but still you have to connect the dots. So now, first of all, there were 6 seconds taken. And after the 6 seconds, what is happening? There was a difference of 80 meters, and out of that, 10 seconds was again covered. So basically, 6 plus 10 is already there. Basically, 1 mark for this thing. Now, because how to earn this 1 mark? D travels 50 meters before colliding. So D plus C, that is particle E, is 48 meters away from Z. The value of k of this particle, the speed, is how much? 15 minus 3 over 4, which is 3 meter per second. So therefore, 48 divided by 3 is 16 seconds. 6 plus 10 plus 16, that comes out to be 32 seconds. Yes, very tough question. Someone said, is it a tough question? Yes, it is. It is. Like, I don't have the threshold handy over here. I think for this paper, the threshold would be like 32 or 33 out of 50. Yes, it's a very tough paper. And wait for the last one. Wait for the last one. That's coming up. That is this thing. Again, the question is there. The first part was very easy for 5 mark, and the second part was definitely tough. So now let's get started with this thing. So what time it is? It's 9:03 and we have time till approximately 9:25. 20 minutes are left, 10 minutes for this question and maybe 10 minutes for the examiner report. So now the question says two particles of masses P and Q, two particles P and Q of masses this thing. So this is P, this is Q. P is the heavy one, are connected by a light and extensible string that passes over a small smooth pulley fixed at the top of the plane. Now that's a standard statement. That is light and extensible string. Hooke's law is not applicable. Light, the weight is not considered. Smooth pulley, no friction. Fixed pulley, no movement on in lieu, on behalf of the pulley. So that is the logic over here. This angle is 30 degrees. It's on the plane. Q hangs below the pulley such that the difference in the level is 2 meters. Now, go to one of these papers. I think it was 2021, November, and I think variant 41 or 42. You can check that out. But I remember 2021, in which a similar question was there. There was a difference in the height, and the second part coming back to the same level, that thing is there. Except for the fact this is rough, that was smooth. The first part, particle P is released from rest and with the string taut and slides down the plane. So particle P released from rest, string taut, slides down, plane is rough, coefficient of friction 0.2, find the acceleration. Now this first part is very straightforward, nothing special. So now the working is right over here. This is about to slide down. This is mg sine theta. This is mg cos theta. This is normal reaction force. This is the weight of particle Q. This is the tension in the string. For this particle, it's upward. For this particle, it's upward. Friction always opposes motion. Friction always acts parallel to the surface. Okay, it was 36. Achha, thank you, Faisal. 36. Okay, that's good enough. So now it says the first thing in a friction question is that first find R. Remember that question over there, that tension and I think 28 degrees and 35 degrees, we also got hold of R first. That was in terms of T. This is in terms in numbers. So R is 2.5 G cos 30. R is this. F max is mu R. This comes out to be 4.33. If you want the exact value, that's right over here. I think the decimals is perfectly fine. So I think it's 4.333. Or maybe it's exact. Just double check. Two particles are there. And now the working is this. Acceleration is this way. Mg sine theta minus tension minus F max is mass into acceleration. Tension minus mg is equals to mass into acceleration. So now over here, mg sine theta minus tension minus F max is mass into acceleration. Tension minus mg is equals to 0.5a. Add both of them. When you add both of them, the tension cancels out. And now what do we have? We have this thing that is mg sine theta minus F max minus the weight is making both the particles accelerate. And then at the very end, we find this answer, round it off, correct to three significant figures. That is the value of acceleration. So the first 5 marks is definitely worthwhile, not difficult at all, just a normal standard procedure that we have to follow. The next one, that is one classic question. Now it says use an energy method. Again, it's for 5 mark. And remember, people, never ever get stuck on a question. If you find it difficult, that means, and after you have done all the thorough preparation, that means other will be finding it difficult also. Just skip that, just continue. Now it says, and come back to it later. I mean, remember that. Use an energy method. So let me highlight this. Use an energy method. Find the speed of the particles. That means they're still connected at the instant when they all are at the same vertical height. Now, a bit of scenario. Now, first of all, this Q is over here. And this time, hold for a second, let me get this thing. This Q is over here. And this Q will move X meters up. Now, let me just charge my Apple Pencil so that there is no issue. So Q is down there, it's moving up, and P is moving down the plane. It's the same distance that they should move. So X and X that you see in green. Now, if it moves up X, how much is left? So therefore, this whole thing is 2. Let me write this as D. So X plus D is equals to 2. X plus D is equals to 2. Therefore, D is 2 minus X. Now this thing right over here, this thing right over here, this thing right over here, that is D. So now let me make a triangle out of this. This is X, this is D, this is 30 degrees, that's right over here. This is D, this is X, this is 30, but D is 2 minus X. So sine 30 is D over X, sine 30 is D is replaced with 2 minus X. So let me highlight this. D is replaced with 2 minus X. And therefore, I get X is equals to 4 over 3. What does that mean? That means Q moves vertically up 4 over 3 meters and P moves down the plane 4 over 3 meters. Now, that is the first thing that you should have it corrected. Now, the working on the next page. Now, this is again classic working. The rule that you need to apply is that is over here. Let me highlight this whole thing. This is the work energy principle that they've asked again. So now I think this paper was kind of an imbalance because they asked this equation in the first question, and now they're asking in the last part. So that's like a bit of overdose. Now, if someone is not very familiar with this equation, that person is getting stuck. And this question was definitely the tough one. Now, use an energy method to find the speed of the particles at the instant when they are at the same height. Now, first of all, what is Q? Q is the freely hanging particle. What is P? That's the particle on the inclined plane. Its height is increasing, its speed is increasing, so kinetic energy is positive, potential energy is positive. For particle P on the plane, its speed is increasing because the speed is the same. They are increasing, they're both increasing because they're still connected. But the height is decreasing, it's going down the plane, therefore the potential energy is negative. So let me again focus on this one. So Q, the height is increasing by X. The speed is increasing by V. It was initially at rest. The height is decreasing by X, but we will be taking the weight component, which is mg sine theta, into this X. And the speed is still increasing. So now over here, let me go back. And now look at the working. Kinetic energy of particle Q half into 0.5 into V square. Kinetic energy of particle P half into 2.5 into V square. Potential energy of particle Q mgh. It's moving 4 over 3 up. Potential energy of particle P mg sine theta into 4 over 3. Change in kinetic energy, positive, positive, will add up. This is 3 over 2 V square. Change in potential energy, this is positive, this is negative. When we add it up, everything is known. This comes out to be negative 10. Just look at the working. I have taken 4 over 3 common. I have taken G common. And this is 4 over 3 and 10. That is taken common. This is 0.5 from here. This is 2.5 into half. That is 1.25. So 0.5 minus 1.25 is 0.75. 0.75 is 3/4. 4, 4 cancel. 3, 3 cancel. Beautiful 10 with a negative sign. Now, unless and until you feel that blood running, gushing fast towards your brain, towards your mind, towards your hand, that is when you get that euphoric feeling that you are doing it all good, all correct. So that's how mechanics question are to be done. Of course, we are not sitting in the exam. We are doing at this moment. In an exam, if such a question comes, don't worry. Don't worry. There are a lot of people who don't know mechanics, in and out. They're not being taught well, unfortunately. So don't worry about that. Others will be finding it difficult. Yes, it's a high level question. Now, Shadab has asked this question: why are the heights different if both are on the same level? The heights are not different. It's just that they both are not vertical. One is on the inclined plane. So just look at the working. This is moving x up, this is moving x down. This is d. X plus d is 2 meters. And then they are connected by trigonometry like this. So q moves 4 over 3 up, p moves 4 over 3 down. It's the same movement, except for the fact that when you use the weight over here, that is simply mg. When you use the weight over here, that is mg sine theta, the weight component. That's the only thing. Now put everything over here. Work done by external force. There is no external force, so this is 0. Change in kinetic energy is this. Change in potential energy is this. Work done against friction. That is the frictional force that's right over here or right over here. That frictional force into distance, it also moves this distance 4 over 3. So this is positive because it's speeding up. This is negative because it is decreasing height overall. Work done against friction always taken as positive. Now just work it out and you get this beautiful answer, which is 1.68. So now someone asked this question in the beginning, are we only going to do one paper? One paper done thoroughly. It's definitely worth it. Now this will brighten up your mind. This will give you insights into what could be coming up next. What are the different types of questions that I've done? Have I learned anything new? Have I done the resolution? I done the resolution in a much nicer way. Did I focus on the angle with the x-axis? Now, these are the takeaways from this session. It's not just one class that will make you just a genius overnight, or maybe you're already a genius, but you need to polish some things. So this class is for that purpose. Last thing that I'll do is that let me go to this examiner report and let me read for question number 7, and then I'll read for question number 6 if possible. The part was well answered. That is the first part. The common approach seemed was to attempt Newton's second law, eliminating the tension. That is what we do, and the required acceleration. And that is, I think, pretty basic stuff. Now, the way that I do it is that particle added up, and that is the system. So I'm confused though as to why mgh of the p particle was included sign as well. Beta, for this thing, what I can offer you at this moment is that, uh, let me just write it down. Hold for a second. So now over here, if this thing is there, so potential energy can be written as mgh, but h has to be vertical. Or if it's on the plane, this is mg sine theta. This is for the plane thing into the distance along the plane. So h is vertical and this d is along plane. So just go through the basics. If you have access to my lectures on Alt Academy platform, just go through it. You will understand it very well. Now over here, this proved to be the most challenging question of the paper. I would say it's the most challenging question, one of the most challenging, one of the top 5 of M1 that ever came. The majority of candidates could not find the distance moved by either particle so that they are all at the same vertical height, with 1 meter being the most common height. They just assume this is 1 meter, this is 1 meter, never ever go ahead with assumptions. The most successful approach was to say that Q moves h meter vertically. This implies that P moves h meters down the slope and hence loses a vertical height of h sine 30. It's the same thing. Now, as the two particles are initially 2 meters apart, h plus h sine 30 is 2, so that the height gained is 4 over 3. I have done it a little bit more trigonometric way. They have not shown any diagram, so the way that I've explained makes life much easier. But I'll just read your comment in a while. Just let me finish this. Once this value was obtained, the use of energy was well done, either on the system or on individual particles. When work done by tension in the string was required, a very common misconception was to assume that P and Q had different speeds. How can they have different speeds when they are just still connected, so they have the same speed? So I think that's about it. I'm all kind of bogged down. Had the P3 paper, the P3 marathon, the M1 marathon. Then I'll be taking a 5-10 minutes break and then going for the S2 paper. Let me read your comment. What are your thoughts on the paper one that happened that would be expected threshold? I have not, the way that I work is that I don't worry about all these thresholds because I don't want my mind to get distracted. Whatever has happened has happened. Uh, it was a normal paper. Nowadays, P1 is getting to the level of P3. So the old days are gone when P1 used to be kid stuff and people would say you have done advanced, you can get away with P1 in a jiffy. Those days are gone now. So things are tricky. Yes, the threshold, in my view, would be around like maybe 59, maybe 62, something like that. That would be P1, but nowadays that's the norm. So get used to it, that P1 will be there. M1, in my view, will be more or less of this type, maybe one or two questions. Part of it would be difficult. Just make sure that whatever you do, at least get 35, 37 flawless marks, and then you can play around with the 13 marks. For example, over here, a worst case scenario is that you would lose all 5 marks. That's the first thing. Worst case scenario in that momentum question is that you would lose this one and this 4 marks. That's 10 marks. Was there any problem with the rest of the 40 marks? No. So just play good with that. I mean, 40 is a very good number out of 50. Now, what happens is that the nerves thing, you have to be very careful. Don't get stubborn. Don't get into a heated debate with the question. Just leave the question and skip. And usually the difficult parts, the difficult questions or the sub parts, they are at the very end. So just focus on this thing. Just focus on the strategy. 45 minutes, first 5 questions, 30 minutes, last 2 questions, and then you are all set on your way to success. Till the next class, take care. Enjoying having you people on board. Assalamualaikum everyone. So now we are back for the last part of the marathon, and it's a wonderful feeling to have a marathon like this. First it was P3, then M1. Now it's time for S2. So now what is S2 all about? S2, as you know, it's about first of all Poisson distribution. Then we talk about this thing that is a linear combination of random variables. Then we have CRV using integration to find probabilities, continuous random variable. And then what else do we have? We have sampling and estimation. And then we have hypothesis for binomial and for Poisson and for normal, central limit theorem. And then we have the type 1 and type 2 errors. So that is the story of S2. Now, let me start S2 in such a way that first of all, let me focus on what you call the examiner report first. So let me open up the examiner report and let me just switch to the main thing. And there it is. So let's look at the examiner report. So I'm solving the first variant of this May-June 2024 paper of S2. And look at the key messages. So let's look at the key messages. I'm just have a look. In all questions, sufficient method must be shown to justify answers. Unsupported answers will not gain full credit. In simple English, what it means is that show every piece of working. Whether you are doing factorization, you are integrating something, you are differentiating something. I'm talking with perspective of P3 also, because P3 is also left. And of course, you can watch this video a little bit later also. So now whether we are doing P3 or S2, we have to show all necessary working. If you do not show the working, the examiner won't be happy. The examiner won't be giving you the marks you deserve. It is important that candidates read the question carefully. I think that is very, very sarcastic and very, very truthful. It's so obvious people are giving A-level exam. Why won't anyone not read the question successfully? Carefully. They have to read it carefully. They have to underline everything like I'll be doing right now. It's a walkthrough video. The solution is there, but still you will see me underlining thing, annotating thing. So I have to make you people understand. So just switch the places. Instead of me, it's you. And instead of the audience, it's the examiner. Make relatable content. That is what YouTube is all about. So the content that you'll be writing on the exam paper, make it relatable to the examiner. That is the way to achieve success. Candidates need to work to the required level of accuracy to 3 significant figures. To maintain 3SF, in final answer, all intermediate working must be to at least 4 significant figures. So those people who have attended the P3 session, they have seen that more or less the same kind of wording is written by the P3 examiner also. For answers that are required in context, quoting general textbook statements will not be sufficient. This is talking about writing a conclusion, writing whether the hypothesis is accepted or the hypothesis is rejected. So in that sense, they are talking about. For answers that are required in context, nothing is done. All working should be done in the correct question space of the answer booklet. Now, this thing I have not even seen in P1 or P3. This is the first time I'm just seeing it, at least for this year. If answers need to be continued on additional page, yes, this thing is there. If answers need to be continued on additional page, all working must be clearly labeled with correct question number. Come on. I mean, I I think the thing is happening is that the examiner is saying, "Hiya, it's not good, it's not correct." That should not how it's done. In order to get a good one. So now, if you want a fuyo, so therefore the way that I'll be explaining it, just follow that thing in complete totality. Now this thing, continued an additional page. That thing is there. Clear presentation of work is of vital importance. In particular, digits must be clear and unambiguous. So now once this thing is done, let me go to the question number, question paper. So it's 9:37. We are starting with this. And one thing they have already explained, but let me explain it further. You should use a calculator where appropriate. You must show all necessary working clearly. No marks will be given for unsupported answer from a calculator. Give non-exact numerical answers correct to 3 significant figures. Degrees are not applicable over here unless a different level of accuracy is specified in the question. That is the main theme. That is what we are working on. Now let's look at the first question. So now let me do this thing. Let me add a page. Let us first look at the question and let me do it throughout the paper for every single page. And in that manner, I mean, we'll be looking at the answer, but first I would like you to think about it. So hold for a second. Let me just do this. And and one part was really extremely funny, or what should I say? I think overall the paper was good. I mean, S2, I find it comparatively easier, and people find it easier to understand. I mean, for me, P1, P3, M1, S1, S2, they all are lovely. They all are wonderful. It's just that how you perceive it. Now I'll be showing you the question and then moving back up. So let's just have a look at it. Take a time and read it thoroughly. So now it says a bus station has 4 entrances in the morning. The number of passengers arriving at these entrances during a 10-second period have independent Poisson distribution. So there are 4 Poisson distribution, 0.4, 0.1, 0.2, and zero point 0.5. Find the probability that the total number of passengers, the key word is total, arriving at the 4 entrances to the bus station during a randomly chosen 1-minute period is more than 3. Now, what do you perceive out of it? Is it a Poisson question? Of course, that's very obvious. It's about total. That means all the means will be added. So now I'll be taking 0.4 and 0.1 and 0.2 and zero point 0.5. That is 1.2. This is 1.2 in a 10-second period. So first of all, let me write over here. So this for 10 seconds, this mean is 1.2. But if we are talking about a 1-minute period, we have to change it proportionally. 10 seconds versus 60 seconds. 10 becomes 60, multiplication by 6. So 6 into 1.2, that you should be doing in the head before you jot down on the piece of paper. Now listen to me very carefully. Now the grade is in your hand. You have studied well enough. You know the formulas. The formula booklet is there. And someone just asked this question, M1 question, but I'll just answer it. Can we use black and blue pen to make diagrams? Yes, you can. You can use pencil also. I'll prefer and use pencil. Now, thank you for the M1 question, but now it's the time for the S2 people who are anxiously waiting over here. So now we are talking about this thing that is this brainstorming should be done. It's a Poisson question. That means what should I do? I should have the Poisson formula ready. I should take care of the number line. I should be aware of the conditions, random and singly, and occurs at a constant rate and independent and things like that. So now let's look at the solution. The question says, in 10 seconds, let me first make a box out of it. So the first thing, first in 10 seconds, this is step number 1. So let me write over here. So this is step number 1. That is in 10 seconds. 1.2 is the mean. This is time period in seconds. And this is the mean number of occurrences. Therefore, in 60 seconds, it's T. This comes out to be 7.2. Now, this is step number 2, which you see over here. Step number 2 is right here. Write down the distribution. Probability x greater than 3. So let me write over here. This is 0, this is 1, this is 2, this is 3, this is 4. Greater than 3 does not include 3. So what should it include? It should include greater than or equal to 4. 4, 5, 6, all the way till infinity. So what is left? We are left with 0, we are left with 1, we are left with 2, we are left with 3. So probability x is equals to r, that is e raised to power of minus lambda, lambda raised to power of r over r factorial. So basically we have done the extended form. That is for 0. This is basically 7.2 raised to power of 1 over 1 factorial. And this one is 7.2 raised to power of 0 over 0 factorial. 0 factorial by definition is 1. Keep that in mind. But you can just write it directly. That is e raised to power of minus lambda 1 plus lambda square over 2 factorial lambda cube over 3 factorial and so on. So that's how it goes. So now we just plug in the values, we simplify, we take care of the accuracy, and this is 3 significant figures. So take care of that. That is question number 1. All good, all clear? So I'll read 2 questions. I'll then go to the examiner report. So read part of it. The second one, okay, this thing is done. So I can just remove this thing from here. Okay, we'll just remove it. Now over here, question number 2. It says the random variable x has a distribution that is normal. This is mean. This is standard deviation square, which is variance. 2 independent random values of x are denoted by x1 and x2 are chosen. Find probability x1 is greater than 3x2. Now the rule over here is x follows a normal distribution mu comma sigma square. If I multiply it by a constant, the mean is multiplied by a constant, but variance is multiplied by constant square. So this is the constant squared, and it's multiplied by variance. Now it can also be written as this. Expectation of ax, that is a times expectation of x, whereas variance of ax, that is a squared times variance of x. So this is for in general random variable, and that is specifically written for normal. So that is the basic diagram. That is the basic working that I'll be doing. So now over here, the question says, x1 follows a normal distribution. So let me get a highlighter ready. So x1 follows a normal distribution 31.2 comma 10.4 square, and 3 times x1 I have denoted it by the symbol y. 3 times x2, that is 3 multiplied by mean, 3 square multiplied by variance, and that is what you get. So now it says x1 is greater than 3x2. I can write this thing as probability x1 is greater than y. So probability x1 is greater than y. So let me focus on this. That means x1 minus y is greater than 0. So now state the distribution. What happens to the mean? The mean gets subtracted. So this is 31.2, this is 93.6, 31.2 minus 93.6, that comes out to be negative 62.4, that's over here. And what about the variances? The variances always get added, and that's the rule. Again, let me write over here so that your memory can be refreshed. That is expectation of x plus y, that is expectation of x plus expectation of y. Expectation of x minus y, that is expectation of x minus expectation of y. Similarly, variance of x plus y or x minus y, that is variance of x plus variance of y. Variance is always added. Now, keeping all this thing in mind, now we have this. Now we are solving this probability x1 is greater than y. Probability x1 minus y is greater than 0. Convert, standardize, that is 0 minus the mean. This minus minus becomes a plus, divided by square root of variance. This comes out to be 1.897. Now let me add this thing over here so that if anyone is weak with this thing, so they know exactly what we are doing. So z is greater than this value. So for example, over here, this is 1.897, and we are interested in finding this area under the graph. So the normal distribution table gives this area. So this is 1 minus 5 of this value, which is 1 minus probability z is lesser than 1.897. You go to the z table, you get the probability value, you do the subtraction, and this answer is what you get. So now 2 questions are done. Those people who are watching it, if they're all good, all comfortable, just be happy. And let me go towards the examiner report. Now, candidates did not always seem the general comments. So let me just highlight this. Candidates did not always seem fully prepared for the demands of this paper. I mean, why? I mean, S2 is the easiest. If I compare it with M1, I mean, it's very, very easy. Questions where candidates perform well were these. Did not perform demanding were 3B, 3C, 5A, 6B, 6C, 7C, 7. So this is 3, 5, 6, and 7. Remember these numbers. Candidates must note that the conclusion to a hypothesis test must be written. Conclusion, hypothesis must be written in context and with a level of uncertainty in the language used. This I'll explain when we will reach that particular part. Timing did not appear to be an issue and presentation was generally acceptable, though there were cases of poor handwriting, digits that were difficult to read, and being given no indication of what it represented. I mean, the last part is pretty sarcastic. Comments on specific questions follow, which identify common errors, though it should be noted if there were some good and fully correct solutions seen as well. So now the first 2 questions we are focusing on. This was a standard Poisson distribution question and was generally well attempted. Errors included use of an incorrect value of lambda, 1.2 being commonly used. That means they did not use ratios. And misinterpretation of more than 3. There were also cases of candidates calculating probabilities of passengers arriving at individual exits. Oh, that means they forgot that it was about the total. There were also cases of candidates calculating probabilities arriving at individual exits. The Poisson distribution, the Poisson expression needs to be shown. Yes, we have shown it. There were few cases of unsupported working. That means if you do not show that what you are plugging in, you will be receiving no marks. Keep that in mind. Linear combo. The solution to this question required finding expectation of x1 minus x2, variance of x1 minus x2. Errors were made mainly when finding the variance. For candidates who made a good attempt at the question, standardizing was usually correctly attempted. Okay. But errors were made in finding the correct probability area. A diagram may have helped here, or the way that I have taught, that would help. Some candidates lost accuracy during working. There were some candidates who did not know how to approach this question. Now, just remember, probability Z lesser than A, that is also written as phi of A, that is direct reading. That is the first rule. The other rules, you can just later on revise them. Probability Z greater than A, this is 1 minus probability Z less than A, which is 1 minus phi of A. This is based upon subtraction. These are the 2 basic rules. I mean, no diagram as such is needed. Even if it's between 2 values, I mean, if you draw it, that's good enough. But once you know the rule, that will make life very, very easy. So now 2 questions are done. Let me go back over here. Now, let's look at question number 3. Now it says, so let me just make it a little bit colder. Now over here, the time taken in minutes for a certain daily train journey has a normal distribution with standard deviation 5.8, random sample of 20 days. The journey times are noted and the mean journey was found to be 81.5, 98 confidence interval for the population mean. A student was asked the meaning of this confidence interval. This was a good question. The times for 98 of these journeys are likely to be within the confidence interval. Explain briefly whether this is true or not. 2 independent 98% confidence intervals are found. Given that at least one of these intervals contain the population mean, find the probability both intervals contain the population mean. So now over here, the first 3 parts, let me focus on that. The first thing, that is a basic standard question, nothing special. So that is this thing, that the 98% confidence interval, 98 is in the middle, 1% at this corner, 1% at this corner. 98 plus 1 is 99%. Z value is 2.326 from the table. You also have that strip we can use. Sigma n x bar z, just use the formula. which is this thing. X bar is z sigma over root n. We get this value that you need to add and subtract, take care of the accuracy. This is the lower bound, this is the upper bound. You can also write it as a bracket. I think that was pretty simple. The next one. A student was asked the meaning of confidence interval. The student replied as follows. The times for 98% of this journey are likely to be within the confidence interval. Explain briefly what the statement is true or not. It's not true. 1 mark for this. The mean of 98% of these journeys. It's not for the individual times as that person, as that student was implying. So this is not true. Not for individual journeys. It's not for individual journeys. It is basically the mean of 98% of these journeys would be within this confidence interval. The next part. Two independent 98% confidence intervals are found. Two independent means two observations. Now remember that binomial is part of S2. Knowledge of S1 is assumed. So it's S1, it's S2, that thing is there. So this is the probability of success. This is the probability of failure. Number of trials is 2. So write it out. X follows a binomial distribution 2, 0.98. It says given. So now it says given. Given is the word that we use for conditional probability. So given that both at least one contains the population mean, find the probability both intervals contain the population mean. So if we talk about both, that is success and success. I can write it directly also 0.98 into 0.98. I deliberately wrote it with binomial. It's your choice anyway. So I have written 2C2, success raised to power of 2, failure raised to power of 0, which is 0.98 square. Probability of at least one, that is success, failure, or failure, success, or success, success. So out of these, if I need this, that is 1 minus probability of 0. 0 means failure, failure. 1 minus 0.8, 0.02 square. Got the idea? Let me explain it further. This is success, this is failure, this is failure, this is success, this is success, this is success, this is failure, this is failure. If I need the sum of these three probabilities, isn't it easier to find this and subtract one? Of course it is. So what I have done is that I have found the probability of zero success, that is both failures, and this at least one, this is your condition, and something relevant out of the condition. This and this and this, that's your condition. We have done it the easy way, 1 minus both failures. Out of this, something goes up. What goes up? SS. So basically, this one is success, success goes up, and success, failure, failure, success, success, success is the condition. That is what we have learned in conditional probability. Something relevant out of the condition goes up. This thing is done. Okay. Now, question number 4. It's about estimation hypothesis, CLT. Now the question says, I'm just reading it directly. It says a random sample of 8 boxes from a certain supplier of a cereal from a certain supplier was taken. Each box was weighed and the masses in grams were as follows. 1, 2, 3, 4, 5, 6, 7, 8. Add it all up. That's 2044 divided by 8. That will give us the mean. And what is the rule? The rule is unbiased estimate of population mean is the same thing as sample mean. So therefore, this comes out to be 255.5. That is one thing that we found out. The next thing, unbiased estimate of sample variance. There are two ways of calculating this. So let me just push this thing to the side. That's right over here. Or we also have this formula. Okay. So what I've done is that I have used the formula for sample variance from S1, and I have rationalized it by multiplication by n over n minus 1. So this you have used in S1, sigma x square over n minus x bar square. This is x bar, it's being squared. What is the meaning of sigma x square? Square each of the values, square, 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 and add it all up. That is sigma x square. divided by n divided by 8. And this is 8 over 7. And that thing is the answer. This is 15.1. That is unbiased estimate of population variance. Okay, now this thing is done. Okay, the next part. The supplier claims that the mean mass of the boxes of cereal is 253 grams. Now it's hypothesis. A quality control officer suspects. Now it's always a relation between claim versus suspicion. So now the claim is made by the supplier. The suspicion is made by a quality assurance or control officer. Now let's read the question again. The supplier claims the mean mass is 253. The quality control has to be sure of that. So he suspects that the mean mass is actually more. In order to test this claim, he weighs a random sample of 100 boxes of cereal and finds that the total mass is this much. Given that the population standard deviation of the masses is 3.5, test at the 5% significance level whether the population mean is more than 253. So now what do? We do this thing, that is that we have a hypothesis. It's related to normal distribution and it's being asked in the end also. Does it say it follows a normal distribution? I don't think so. It does not say it follows a normal distribution. So how can we assume that it follows a normal distribution? So the very first thing that needs to be done is this. That is, n is greater than or equal to 30, CLT applies. That's the first thing. So that should be step number 1. That is, since the sample size is large, what is the sample size? 100. CLT applies. So this becomes approximately normal distribution. That is the first thing. Now, whether the examiner asks for it or not, I'll still justify it. But over here, they have asked it in another way. That is, that an employee says this test is invalid. Let me just erase this. An employee says that this test is invalid because it uses the normal distribution. But we do not know whether the mass of the boxes are normally distributed or not because it was not stated. So how would you justify it? Explain briefly whether the statement is true or not. So we will say it's not true. Why? Because since sample size is large, n is greater than or equal to 30, CLT applies. It is now approximately following a normal distribution. So yes, go ahead and use normal. Perfectly good, perfectly fine. Coming back to this. Now over here, the step 1 is done. What is step number 2? Step number 2 is the distribution, the sample mean, distribution of sample mean. X bar follows a normal distribution. The mean remains as it is. The variance is divided by the number of sample. What is step number 3? Step number 3 is write down the hypothesis. So what is the hypothesis? Mu is 253 and mu is greater than 253 because it's an upper tail test. And definitely we have the significance level. And then step number 4, that is calculate the test statistic, the z value. What is the test statistic? It makes the decision. It's a decision maker. X bar minus mu divided by sigma square over n, the whole thing under root. So let me just write under root over here. Let me write under root over here. So this z value comes out to be 1.714. And the last step, that is step 5, that is of conclusion, drawing conclusion. What is the conclusion? It's an upper tail test. So focus on the upper tail. Because of the 5% significance level, this z value is 1.645. We have to see whether our calculated z value, keep in mind, this is 0 over here. The numbers are increasing on the right. So the numbers are getting positive over here. Does this z value lies in the critical region? Yes, it lies in the critical region. Therefore, reject H0, accept H1, but do not stop over here. This is a textbook definition, but go ahead. I'm writing in the context of this question with a certain level of uncertainty. There is sufficient evidence, yes, there is, but at which level? At 5% significance level, that the mean mass is greater than 3 to 53 grams. So you have to write there is sufficient evidence if we are rejecting it. There is insufficient evidence if we are accepting H naught. We fail to reject H naught. Mention the significance level, that is the 5% level. The mean mass is greater than 253, right, in the context of this question. Just simply don't stop over here by saying reject H0, accept H1. That is good, that is correct, that is step in the right direction. But, in the context of this question, you have to write the explanation. All good, all clear? So now this question is, I think, question number 4, that's done. Now let me look at question number 5 and then I'll write it. Now someone again asked this question, Two Nation Gaming. Sir, M1 में forces के diagram pencil से या pen से? Diagram, whether it's S2 or M1 or maybe P3, always draw with a pencil, because diagram, they are not giving you separate marks. So draw it with a pencil so that if there is any issue, you can erase it. Okay? Later on also, if once I'm done with the exam, if in the same stream, if you have any comments, any questions, you can ask me directly. You can ask on this channel. Everything is there. So now it says this one, question number 5. Sales of cell phones at a certain shop occur singly, randomly, independently. These are the different conditions that is related to Poisson distribution, the mean number of occurrences. They occur singly, randomly, independently, and occurs at a constant rate. These are the 4 things. Average constant rate. I think let me add the word average also. Average constant rate. Now, what does that mean? The sales occur in such a manner that one person arrives at the shop at one time. The sales occur randomly. One person is not convincing the other person to buy from this shop. Randomly, it also means that, let's say, 10 phones are sold in 1 hour. Or let me make it 12. If 12 phones are sold in an hour, it does not mean the phone is sold every 5 minutes. Yes, we do talk about the average rate, but that does not happen in reality. Maybe in the first half an hour, not a single phone was sold. And then in the next half an hour, all 12 phones were sold. So that is randomly. Independently, one person is not convincing the other. Sales occur at a constant rate. That means when you take an average, you can say that this occurs at a constant rate, as we have seen in the first question. That was about the total entrances at a particular gate or something. So the first part is done. The second part, the average number of sales per hour is 1.2. Assume now that a Poisson is a suitable model. Find the probability that the number of sales during a randomly chosen 12-hour period will be more than 12 and less than 16. Now, 1.2 per hour, therefore in 12 hours multiply, that's 14.4. It's not a normal distribution question because the condition over there is lambda is greater than 15 for it to become a normal. It just missed the bus. This is 14.4. X follows a Poisson distribution, 14.4. Probability X lies between 12 and 16. 12 is not inclusive, 16 is not inclusive. Let me draw a small number line over here. So therefore, let me get a black marker. This is 12, this is 13, this is 14, this is 15, this is 16. It lies between 12 and 16, greater than 12 and lesser than 16. But neither is 12 included nor is 16 included. So which 3 are included? 13, 14 and 15. Now show this working. This is what the examiner is saying when it asks you to show the working. E raised to power of negative lambda. Lambda raised to power of 13 over 13 factorial, 14 over 14 factorial, 15 over 15 factorial. Use a scientific calculator, use brackets, get the answer, write the answer correct to 3 significant figures. how would we know the difference when to do the approximation? देखें, when we talk about approximation, let me just use the space. One box, two box, three box, and a fourth box. If we talk about normal approximation to binomial, let me talk about normal approx to Poisson. Let me talk about Poisson approx to binomial. Let me talk about central limit theorem. I think these are the four things that we work with. We know that expectation of x is np, variance of x is npq. If np is greater than 5 and nq is greater than 5, then x follows a normal distribution np comma npq. Keep in mind, this is nq, this is not npq. Keep that in mind. This is nq, this is np, that is the condition. Over here, expectation of x is lambda, so is the variance of x. If lambda is greater than 15, then x follows a normal distribution, lambda comma lambda. The mean is lambda, the variance is lambda. Over here, Poisson approximation to binomial are really helpful. Please help with that one. We have to find type 2 error. Yes, we will be coming to that. Poisson approximation to binomial. So over here, we will write that the expectation of x is np. If n is greater than 50 and np is lesser than 5, then x follows a Poisson distribution with np. That means when we talk about Poisson approximation to binomial, binomial becomes Poisson. Normal approximation to Poisson, Poisson becomes normal. Normal approximation to binomial, binomial becomes normal. Over here, when it is discrete and continuous, there is continuity correction, there is continuity correction. Over here, there is no continuity correction. And what is CLT? If n is greater than or equal to 30, CLT applies, and just use mean and variance and plug in normal distribution. Okay, so now that is the working that can be done. Okay, so now some people, they ask this question that sometimes helpful, type 1, type 2, that thing is done. As in S1, they already tell us to do the approximation. No, not always. You have to basically find it out. Now you have this thing, you can find it out, and you can go across it. So now this thing is done, 5 is done. Now this is the one. Now just look, have a look, you are in good luck, you have this thing. Now it says use a suitable approximating distribution. Find the probability that the number of sales during a randomly chosen 1 month period will be less than 150. So now use a suitable approximating distribution. Now 140 hours. So 12 into, 1.2 into 140, that is 168. Now lambda is greater than 15. So expectation of x is lambda. Let me also write this. Expectation of x is 168. So is the variance of x. Therefore, in place of mean, we have 168. In place of variance, we have 168. Probability x is lesser than 150. Let me also show you this. This is 150. This is 150.5. This is 149.5. Lesser than this, lesser than this. And which one do we choose? Less than 150, choose the one that does not include 150, which is 149.5. Then standardize. Then get the z value. Z lesser than negative value, z greater than positive. This is because of symmetry. And if you want me to draw a diagram, so let me just draw a diagram over here. Basically, what we do is that greater than 1.427. So this is what you are working for. So this is 1.427. That is 1 minus 5 of 1.427. Go to the table, use the z value, read the probability value, subtract, and this is the answer correct to three significant figures. So that thing is done. I think S2 is very interesting and very straightforward. Okay, thanks for the appreciation, sir. Use a binomial, nothing is done. Now let me, before we go to question number 6, let me go to the exam report. Okay, Jay. Confidence interval in S1. The knowledge of S1, that was conditional probability that was used. That is the main thing. Finding unbiased estimates of population and mean and variance was well attempted. Majority candidates found, but errors were sometimes made when calculating the unbiased estimate of variance because they were not using the right formula. Errors made calculating unbiased. Often use an incorrect formula. The question was reasonably well attempted with hypothesis often correctly set up and a standardizing equation. There were, however, candidates who omitted to state their hypothesis. That means whether they asked it or not, do state that. And errors in standardizing equations were mainly due to omission of root 100. They forgot to divide the variance by 100. A comparison needed to be clearly stated to justify the conclusion. This is best shown either by an inequality statement or alternatively between areas, thus leading to the conclusion which not be a definite statement and must also use the context of the question. That means I have shown it using that graph. I think I love that. I will follow that and I want you to follow that. Concluding that the mean mass had changed was not acceptable as the evidence was sufficient to show that the mean mass had increased. And the main thing over here, right in the context of the question, that is very necessary. If you do that, if you get everything correct, then it's a good thing and you'll be getting your marks. Question 5, that is this thing. The part was not always well answered. Many candidates were unable to state the further condition required. Why? I think they were unable to just figure out that the average rate was asking, often merely repeating conditions already given. I mean, that is something. That is something. And comments such as the mean and variance need to be the same were often seen. Condition is different. Once it is a Poisson distribution thing, then mean and variance definitely will be equal, but that's not a condition. Condition is singly, randomly, independently, average constant rate. This part was particularly well attempted, though some candidates gave an unsupported answer. The requirement is that all working must be shown, so that Poisson approximation needs to be clearly seen. Errors included incorrect values of lambda or an extra or missing term in the expression. That means 13, 14, 15. Somebody might have included 12 and 15 also. Somebody included 12, 13, 14, excluded something also. So that is the basic idea. Again, this part was reasonably well attempted, usually correctly chosen as the approximating distribution. Errors included a wrong or sometimes missing continuity correction. So what needs to be done? Draw a number line. So the proper way is number line and no compromise on that. So now question 6 and question 7 are left. Let's go to that one. And the marathon is really a fun, especially with you people. I mean, writing all these comments and giving me the support and everything. I mean, that is really helpful. So now let's look at this. The diagram shows the graph of the probability density function of a random variable x. The graph is a quarter circle entirely in the first quadrant. So this is the full circle, but no, that's not a beautiful circle. That's a full circle. This is a quarter circle with center 0, 0 and radius a. This is a, this is a. Where a is a positive constant, elsewhere fx is 0, show that a is this. Very simple. The area of the quarter circle, that's 1/4 pi r square. A question like this has appeared before in this thing. So therefore, since it's a PDF, it's a CRV. Let me also write CRV. Therefore, the area and probability equals to 1. So pi a square equals to 1. Therefore, a is 4 over pi square root or 2 over root pi. That is what is given over here. Very basic. Show that fx is this. Now this is again P1 in full action. That is about equation of a circle. I mean, can you believe that they will be asking equation of a circle? I mean, which sometimes I feel that it should not be so much purely mathematical. It should be more statistics based. Yes, P1 is already asked elsewhere. P3 is already asked elsewhere, so it shouldn't be used over here. Well, that's just my 2 cents on this. X minus h whole square, y minus k whole square is r square. So h and k, that is the origin, radius is a. So x minus 0 is x square, x minus 0 whole square is x square, y minus 0 whole square is y square, a square. A square is already given, that's 4 over pi. So a square is 4 over pi, 4 over pi minus x square. That is why instead of y, they have written fx. As simple as this. Now wait a minute, a big RXS shift or something like that. On the next page, don't jump. Just hold for a second. I think that was over here, or maybe the other page. Now look at this. Show that expectation of x is this thing. Now this is too much. This is too much. Expectation of x, that is this thing. That is what? That is x into fx and then integrate, right? We have fx, we have x. What's the big deal? The big deal is that was P3, that was P1, this is P3. That is integration. I mean, this is not good. This is not good. This is too much. We cannot remove this square root. I also got puzzled for a second. Yes, they have asked about integration by parts in the beginning and sine, cos, and ln. Now, seriously, no, this is not integration by parts. This is substitution. That is even worse. So now over here, the rule is substitution, algebraic substitution. What is the rule? Anything that's trapped inside a bracket. So now this is trapped inside a bracket. So that thing should be taken as u. Once you realize that, it's not that difficult, provided you are doing P3, which of course you are. But I mean, at that moment, who would think that they have to do substitution? I mean, seriously, I mean, this is too much. So now over here, u is 4 over pi minus x squared du. This is 0, minus remains as it is, x squared becomes 2x dx. So now let me change this thing. Let me use a red marker, this x and this dx. This is du and negative half. So x and dx, this is minus half du. This is changed. Okay. And this thing over here, 4 over pi minus x squared, that's already u. And there is a square root at the top. So now look at this. We have the square root of u, negative half du. Limits are also changed. How will we change the limits? According to the same equation, 4 over pi minus x squared. When x is 0, 4 over pi minus 0, which is 4 over pi. When x is 2 over root pi, u is 4 over pi minus 2 over root pi square, which becomes 4 over pi. Therefore, this comes out to be 0. A small value is giving you a big number. A big number is giving you a small value. The rule is place limits where they belong. If they came from a lower limit, place it for a lower limit. If it came from an upper limit, place it for the upper limit. So this is lower limit, that's 4 over 5. This is upper limit, that is 0. So this is lower limit, 4 over pi, upper limit is 0. This is after the substitution. This is after substitution. Now, just integrate. That is very easy. So now when you integrate it, this is u raised to power of half. Half becomes 3 over 2, division by 3 over 2. And it becomes minus half into 2 over 3. 2 cancel, minus 1/3. What is the next thing that I've done? That you have seen in P1, I have done it over here. I have changed this plus and I have changed the position of these two limits. That you can do. If someone is unfamiliar with this, let me write it. If I integrate fx between the limits a and b, that is the same thing as integrating negative fx between the limits b and a. So just change the limits. Just change the limits like this. So that's the rule that I've applied. It's not necessary, but I've done it. So now over here, What do? We plug in the upper limit. When we plug lower, that's 0. So 4 raised to power of 3 over 2. Now another thing, I mean this person, this examiner is too much obsessed with P1. I'm sorry for that, but that person is. So now let me just erase this and let me show it. So 4 raised to power of 3 over 2 can be written as 4 raised to power of 3 raised to power of half, 4 raised to power of half raised to power of 3. This is 64 square root, that comes out to be 8. 2 raised to power of 3, that comes out to be 8. So therefore, let me grab this thing. Let me push it over here. Let me erase this red thing. And let me just write it like this. Okay. So that's how it is done. Similarly, we have this thing that is pi raised to power of 3 over 2. That can be written as pi cube square root. So let me just clear this thing over here. So pi raised to power of 3 over 2, that can be written as pi raised to power of 3 raised to power of half, that is pi raised to power of 3 square root. So that thing is over here. And this thing is over here. And this 1/3 is there. And that is the answer for this part. I mean, that is one CRV starry question. So I'll give it a 4-star, and that was too much. So that was P3. And over here, this is P1, and it's P3 and P1. And what else is there? This is indices. I mean, there is too much of pure maths in this. Yes, yes, yes. Oh, so what a question. What a question. Now, the last question, and that is like the end of the marathon for me also. So, I mean, this is the first time that I've done like 3 papers in a single sitting. I mean, it's worthwhile. That sense of satisfaction that you feel by giving last minute support to students, I mean, that is really worthwhile. So now over here it says, every July, as part of a research project, Rita collects data about sightings of a particular kind of bird. So this is Rita and a bird and the month of July. So let me highlight this. Let me use a very light color. July, research, Rita, sightings of a particular kind of bird. Each day in July, she notes whether she sees this kind of bird or not, and she records number X of the days on which she sees it. She models the distribution by binomial 31 days, and P is the probability of success. That is the probability of seeing this kind of bird on a randomly chosen day in July. It's all about the month of July. Data from the previous years suggest that P is 0.3, but in 2022, Rita suspected, again the claim and the suspicion, that the value of P has been reduced. That was upper tail, this is lower tail. She decides to carry out a hypothesis test. So like a hypothesis test in real life. In July 22, she saw this kind of bird on 4 days. First part, use the binomial distribution, test at the 5% significance level whether Rita's suspicion is justified. First thing first, that is the distribution X follows a binomial distribution 31, 0.3. The second thing, that is stating the alternative and null hypothesis. So this is null hypothesis, this is alternative hypothesis. The next thing is the sample value, which is 4. Since it's a lower tail test, and by default this value is inclusive for calculation of probabilities, we should calculate the probability in the lower direction. So 4, 3, 2, 1. 31C0, success raised to power of 0. 31C1, success raised to power of 1. 31C2, success raised to power of 2. 31C3, success raised to power of 3. 31C4, success raised to power of 4. And failure raised to power of difference between the two, because the total should add up to 31. I mean, that is another takeaway from binomial expansion of P1. This comes out to be 2.39%. This is in decimals. I convert it into percent because I have to do the comparison. I have to compare the p-value if it's lesser than the significance level percentage, the p-value percentage. If this is the case, then reject H naught. If it's not the case, then we won't reject H naught. As simple as this. So over here, 2.39% is lesser than 5%. Reject H naught, accept H1. There is sufficient evidence. At which percent level? How much percent is this? At the 5% level. At 5% level, to suggest that the probability of that bird sighting has decreased, her suspicion is true. That is binomial. The next one. In July 2023, she notes the value of X and carried out another test at the 5% level using same calculate the probability of type 1 error. Probability of type 1 is basically probability of the critical region. So we don't know what the critical region is. When we have a lower tail test, we have 0, we have 1, we have 2, we have 3, we have 4, we can have 5 or something like that. So now this is 2.39%. There is space till 5%. So what we do is that we have already calculated the probability of 0, 1, 2, 3, 4. Let me calculate the probability of 5 also. And let me add it up. But now this is 6.27%. It has suddenly drastically increased. If it remained lesser than the significance level, we would include that. That means the critical region is 0, 1, 2, 3, and 4. What does that mean? That if you lie in the critical region, you would reject H naught. And do watch all the videos. I mean, this concept is not that simple that it could be taught in a session. So you have to watch the videos. Probability X is less than or equal to 4. That is this thing. That's the probability of type 1. So type 1 error is basically reject H naught when H naught is true. And that is the probability of critical region. On the other hand, if we talk about type 2, that is accept H naught when H naught is false. If H naught is false, then H1 is true, and they will give you a new value of either P or lambda or mu, and then you have to accept H naught. So these are in opposite direction. Got the idea? So you just change the direction and use a new value, you get probability of type 2 error. Last part. Now it says Rita models the number of sightings Y per year of a different very rare kind of bird by the distribution such and such. Use a suitable approximation. Now you people are in luck. We did something with CLT. We did something with normal approximation to Poisson. And now we are doing Poisson approximation to binomial. So you will write this thing. Y follows a binomial distribution such and such. That is N, that is P. Expectation of X is NP. That is 3.65. Now, what is the condition? The condition is this: since n is greater than 50, np is lesser than 5. Therefore, this expectation would be used in place of lambda, because expectation is another name for lambda, that is mean number of occurrences. So now y follows a Poisson distribution 3.65. Probability y is equals to 4, just one term, that is e raised to power of negative 3.65, 3.65 raised to power of 4 over 4 factorial, and you get this answer correct to 3SF. And justify, I've already done. I never work without justification. That's part of life, that's part of S2. So that is the wholesome overview of this particular paper. Just go over your basic notes, go over anything that you feel that is weak, that's your weak area, strengthen it, always start from the basic, and that's all about it. So till the next class, take care, and it's time to sign off with this math marathon. So how do you end this thing? You just go over here and you finish this thing. Take care, everyone.